The Earth is very flat.
What's going on, everybody? It is Thursday, August 19, 2021. This is Brandon, host of Brandon's Show. What's happening? Hope everybody's doing good out there. And this is a show where we acknowledge that someone is trying to distort our reality. And we're here to find out who it is and why they're doing it. It's a long journey, but we'll get there. Anyway, let me say hello to everybody in the chat. Page 42, Askin Razib, Mojo Shop, Fuzzy Bush Monk, Anders Ace, Brandon Cook, PJ Cruikshank, Cleary, back. Good to see you back, Cleary. And Whitesword, what's up, Whitesword? Bill G, can't wait for the sophist. Oh, they're coming, buddy. They're coming in droves, let me tell you. You don't have to wait long. And PJ Cruikshank was first. Congratulations, PJ. First 5. That's pretty good. Let's see. I'm looking for Bill's comment. Where are you at, Bill? I'm lost without you. Is my mic working? Hello, hello. There it is. Anyway, let's go into Discord. There's already a lively discussion in there with 35 people. If you're not in our Discord, you're missing out. It is started sometime last week to turn into a 24/7 hangout in voice. So now there's always people in there. We have good moderation, great moderators in there. But, you know, we all fuck up a little bit. Gets a little heated, but for the most part, great moderation. Very few rules, just basic human decency. No litmus tests. Come in there and discuss. Just be warned that we are infested by paid shill trolls, and they're useful idiots, and they're very active in the chat, so don't get discouraged. You got to have a tough mind at this point to be in this discussion on either side, really, but mostly on the flat earth side. All right, guys, let's head in there and see what's going on.
And have more than standard refraction. So let's look at this case more
Your
carefully.
argument
and you do
states is this: if we're going to use 7/6R, you're basically saying that refraction is flattening the Earth. It's absolutely moronic, because then it would be completely an optical effect, which wouldn't be measurable or calculable. And if that's true, you wouldn't be able to. If that was true, you wouldn't be able to. If it wasn't, if it was, no. What do you mean that's a lie?
That's a lie.
Then you're trying to. Then you're trying to derive a base value.
I'll let you finish, and then I will tell you how it's a lie.
You're trying to tell me as an argument, your argument, that the Earth will appear flatter due to more refraction using 7/6R, not standard refraction.
What it's saying is that you can see farther.
Yeah. So that's what you're saying. So again, you're even making your argument worse, because you're proving the point. You're proving the point of the flat earthers is the horizon. You're proving the point. You're proving the point of flat earthers that the horizon is due to an angular limitation due to atmospheric conditions and optics. This is why when you use cameras, you have several. When you use cameras, you have several different interpretations of the environment, because the natural environment is fluctuating and has nothing to do with Earth curvature. That's why
RC, hold on, RC.
That's why you think that the Earth appears flatter when you can see farther due to optics.
So that means
due to optics.
Here's an easy way for you to see that you're wrong.
You back up our argument, because we know that the horizon is not due to physical Earth curves, it's due to optics.
I need you to finish at some point, because I said a long time ago that I'm going to tell you where you lied.
When you claim refraction allows you to see you farther, you just back up our argument that it's not due to physical Earth curves.
Data, your argument is right now hinging on you talking so much that no one else can.
So here's
you just confirm. Just so you understand.
You need to shut the hell up and let me respond.
Hold on,
Otherwise, this is not an honest discussion.
You guys can't seem to not talk over each other. Let's let RC jump in for a sec. Go ahead, RC.
Thank you. So here's a very easy way to show like how full of crap this argument is. Okay, and all you have to do is take 100 measurements between 0 and 1,000 feet, and then ask yourself, okay, how far can I see? And what is the function? What is the variable that changes how far I can see? And where does that variable seem to deviate? The answer is, if I take a photo from 0 to 1,000 feet and how far I can see. Once I get about above 100 feet, it's incredibly predictable. So you ask yourself, why below 100 feet do I get so much variation? And the answer is I'm looking through, the only difference is I'm looking through more atmosphere, and that more atmosphere is going to give me more optical effects. So the question actually is, if I take 100 measurements between here and 1,000 feet, why above 100 feet
bro.
do I get
Does the ground?
I'm finishing my sentence.
Yeah,
So be
RC,
quiet. I'm
RC,
finishing my sentence. Be quiet. I'm finishing my sentence. So why, when I get above 100 feet and I'm taking 90 more measurements, do I have incredibly predictable results?
So what you're doing is you're going up, and when you go up, does the ground extend outward in front of you, or does it dip down away from you when you would go up? What's the natural function?
Why do I get more predictable results?
What's the natural function? Well, here's the issue with your statement is that it's false in two regards. Is that if you go higher up at a shorter distance between 2 points, you'll have less refraction. But in the same term as the higher you go up, the longer you see, so therefore you're seeing through more refraction. So you have an ad hoc argument again when you're not putting the true variables, when you're putting the true variables into position. Again, if you're going higher up between, you're going at a higher position between 2 points, you're going to see clearer. But if those two points are extended outward, as when you increase in elevation, the land goes outward from you. Okay. It doesn't dip or drop away. It goes outward from you. So
why is that?
So because the Earth is an extended plane, there's no dip, no drop, no curvature. There's nothing that matches the 3,959 miles as far as 8 inch per mile square goes. You can easily deduce that that doesn't match reality the higher you go. So for some reason, it hasn't caught on.
That wasn't my question, Data. You didn't listen to my question. I said, why does it vary more under 100 feet and doesn't vary at all 100 feet and above?
Yeah. Again, why don't you show me an example? Why don't you show me an example instead of telling me a story?
Sure.
Okay.
No problem.
Saying it doesn't vary at all.
Yeah, no, here you go.
Saying it doesn't vary at all is false.
I didn't say that. I said I didn't say it doesn't vary at all. I said it varies wildly under 100 feet. It doesn't vary very much at all in comparison 100 feet and above. So here's a good example. Here's a good example. So there have been approximately 25 photos shown of that, like just stills that I have seen of the black swan image, or at least those platforms. All of them taken from between 1 and 5 feet, or 1 and 6 feet, as it was claimed. So the question is, okay, we have like these 25 between 1 and 6 feet, but then we have multiple observations of 100 feet, 200 feet, or even 1,000 feet above that spot there, and there's hardly any variation with how far you can see. So there's one example that you get tons of variation in the black swan photo from one day to the next between 1 and 5 feet, but you get next no variation once you get 100 feet, 200 feet, 300 feet.
Hold on. Okay.
Show us.
Okay. I have a question. Hold on. Okay, so just for clarification, when you said that you changed in what you're describing, when you're moving away from where BMLSB took his shots, are you saying that you have many shots of that same observation, but from a higher elevation? Is that what you're saying?
Yeah, you can get them from a higher elevation.
No. Not you can. Okay, because if you're saying you can,
there are from higher elevations. Yes.
Okay, of that same observation.
Yeah, from the same spot.
Okay, please produce those.
I'm driving right this moment. I can't. So
where are they?
Here's the
I've
reality.
Never seen them.
Listen. Here's the reality that I'm actually asking a question about.
Real quick. Just chill out, RC. Chill out, real quick. Chill out, RC.
The question is,
RC,
why does it vary so much between 1 and 6 feet?
We need to see the observations first, RC.
Chuck, listen, hold on, RC, listen. Data just told you why, okay? And I agree.
No, he didn't tell me why.
Hold
he
on.
Didn't actually tell me why.
Hold on.
Tell us why.
Yes, he did. I understood exactly what he was saying. Okay, shut up, Lars.
Can you then explain it
to RC? Okay, listen. Again, I know Bo personally. Okay, so I haven't seen anything from him from a higher elevation. So who's your source of these higher elevation observations?
Ask him for his 25-foot observations that taken farther back from the beach and up. Ask him for those.
25.
I think
Okay,
I'm
look.
watching
Okay,
it.
look. Okay, look at 25 feet.
Yeah.
Okay, I've been there.
Yeah.
I have shot from those exact
Right.
locations.
And so
Okay,
if you
so
go up
I've done
towards the
that.
building, if you go up towards the buildings that are there on the beach, you go up towards the buildings, you know that's about 25 feet above sea level.
Okay, what's your
Travis,
fucking
why are you
point,
even
dude?
arguing with
When
him?
he
What
takes
the fuck
when he
is he
takes videos
talking
from
about?
25 feet. Hey,
RC,
You know why?
RC,
When he
you
takes
gotta
videos
bring
from
some
25
fucking
feet.
evidence.
Yeah.
You're just
When
you're
he
just saying a
doesn't-
bunch of shit. We haven't even seen it.
listen.
You're about
When
to
he
use
takes
standard
videos-
refraction anyways, and you can't prove
When
ours.
he takes
so-
videos from 25 feet, there isn't as much variation.
Why would there be? You need to show us what you think is wrong with the 25-foot elevation.
I didn't say that there's anything wrong with it. What I said was I'm addressing this argument that you say, oh, there's all these things between 1 and 5 feet. There we get these wild variations, and I'm saying, okay, cool beans. Compare that to when you try to take it from 25 feet or 75 feet or 100
Why would
feet
those
or
matter?
200 feet.
We're talking about lower to the
Because you
ground.
get
We
a
can
bunch-
see
You
further.
get a bunch of variation.
There's
You get
software out there
variation.
that'll do
You're
this.
really close to the
This
surface.
is a red herring. This is a red herring.
Here is
You don't get a lot of variation when you get higher up.
This is a red herring.
here is how it matters. Flat Earth Data was making his point that the effect that we see is only due to the atmosphere, and that's what I'm saying. And he's actually completely, and that was what I said when I said he's lying. It's not just the atmosphere, and we can eliminate actually what RC is bringing is actually very good, because then we can, just by slightly having higher observations, we can eliminate the atmosphere, the most drastic atmospheric effects,
No, you
and
can't.
the bloody effects will be still like
No, you
we can
cannot
still see things here.
eliminate
Yes,
the
you
most.
can.
You cannot eliminate the atmosphere from a view
Listen
of the
closely to what I
horizon.
said.
Hold up,
You
Floyd,
cannot.
We're not,
Listen,
Brandon, I'm not
Brandon,
saying that you
listen
eliminate
closely
the
to what
atmosphere.
I
I'm
actually
asking
said.
one
I
quick-
said you
I'm
can
asking a
eliminate the
simple
most
question. Hold up.
drastic effects.
I'm
Let's
asking
see
If you
it.
one
disagree
Show
simple
with
it to
that,
us.
then you're wrong.
I'm asking
Show
one
it.
simple question that I want an answer to. Why is there so much variation from day to day when their observations are taken between 1 and 5 feet? But if you take it from 25 feet, there isn't that much variation.
Variation of
To what? Variation
What
to what,
variation?
though? We need to see the
Variation
observations and we can analyze them.
Variation of how far
If you're
you can
looking
see.
at a shorter distance from higher, I would agree there's probably going to be less variation. If you're looking further, then you'll still have that variation.
No, I'm asking
No
why is there
variation.
a
It's
ton
all
of variation
optical.
at 1 to 5 feet, but not that much variation at 100 feet?
Well, you
or
need
200
to
feet
show
or
us the
25 feet?
observations before we can really tell you anything.
Oh, okay.
Yeah.
But there's also, I mean, the
And
density.
no one's going to tell
density
anybody anything
layers.
without the computer software either. I can't believe y'all are doing this just on a whim when there's tools out there that can help you explain both sides.
In terms of altitude, I would say there's
Huh?
definitely density layers. There's lensing. There's all kinds of things that happen at ground level versus like when you're up in an airplane. Of course, the sky is much more clear. You can see a lot further versus being on the
Why
ground.
is-
So there's a dramatic difference because
Yeah,
you're
my
looking
point
through
is,
a different.
I'm asking you.
You're looking
I'm
through a
asking
different
you a very
section of
simple question.
the ether.
Why, I'm asking you a question, very simple one. Why is it that you see clearer when you get higher?
Because you're seeing through a completely different layered components
Good
of
job.
the ether.
Good job.
You
Thank
don't
you.
you
That's
don't
my
see
entire
clearer when you're higher. You don't. That's not necessarily true. That's kind of a
Very true.
simplification of what happens. When you go up in
No, it's
height, you can see
incredibly true.
further, and at shorter distances that were more impacted on the ground, it may be clearer. But at further distances, it's still fucked up.
Okay,
You still can't see clearly.
here's a very good question. Here's a question just for everybody to think about real quick. Can you see a mirage at 2,000 feet?
What kind of mirage?
Any mirage.
I don't know. The
Ask you-
horizon is so
There is
compacted by that time that when you're looking out that far,
Yeah.
the physical
Right.
space is squished so much into visual space that you can't even make anything out near the horizon
Okay.
that high.
All right. So my question is, why don't we get things like looming effects from 2,000 feet? Have you ever thought about
How
that?
do you know you don't?
Okay, wait. Hey, listen, RC. You're just making shit up off the top
I'm
of your
not.
head, dude.
I'm not.
Give
Go
us
ahead, Data.
examples.
Respond
Listen.
to me. Why don't we get looming at 2,000 feet?
Do you have
No,
Travis
that's a stupid
muted?
question.
Travis is speaking, RC. I don't. You might have him muted or something.
I don't.
RC, can you hear me?
I can hear you. Go ahead.
Okay, do you have an observation from 2,000 feet you would like us to consider, please?
Yeah, sure. When I get to my destination, I can send it. But I'm actually asking a question. Do you get? Has anyone ever here ever seen looming?
I need to
Looming or
see the
sinking?
evidence.
Listen, I'm asking you
Travis?
for evidence. Have you ever
How
seen
would we
sinking or
know
looming
if
at
we saw
2,000 feet?
looming at 2,000 feet?
Yeah, that's my point. You don't see looming or
How would we
mirages
know
at
if we
2,000.
saw it?
You don't see it. Why?
How would we?
Because
Yeah, exactly. But how do we
atmospheric
know it's not there? Just because you can't identify it? Is that what you're saying? You can't point
if
to it and
you-
go,
are you
"Oh,
claiming
this
that there
is." I don't know if there is or not. I don't know what
I'm
point you're
actually
trying to
pointing
make.
out-
You're just throwing random
actually
shit out
pointing
as
out-
far as I'm
No,
concerned.
no. Here, let me make my point then. At 2,000 feet, you're not
Well,
going
hurry
to
the
get
fuck
things like
up.
mirages because there's a lot less atmospheric effects because there's less atmosphere.
No, there's
Because of
less
that level,
atmospheric
you have a question,
effects
you get a much-
below
you get a
you.
much
It's all
crisper-
about the
you get a much
angle. When you
crisper
look out
horizon.
towards the horizon in the distance, you're still going to have atmospheric effects. You've still got light going through the thickest part of the atmosphere to get
Sure.
to you. It depends on how far you look out.
However, you're not going to get things like any type of looming that you can discern.
You don't know
or
that.
mirage.
Prove it. You wouldn't be able to see it. The physical space is so compacted in your visual space when you're looking out that far at the horizon. You don't know
You
what
want me
the
to
fuck's
prove a
going on out
negative,
there.
Brandon? Really? You want me to prove a negative?
No, RC,
You're
I have
asking
a
me to
question,
prove
RC.
that it is there. How the fuck can
No.
I prove it is there?
Because I'm trying to point out to you that you take all these observations from 1 to 5 feet and try to draw conclusions. I'm saying, wait a minute, why don't you try to isolate a variable of optics by taking out a lot of those variables? AKA,
You
give
didn't
us
take any of them
atmosphere, go higher.
out. You didn't take any of them out.
RC, I have a couple questions, RC. Can I ask you a couple questions real quick?
Sure.
Okay. Do you know what conditions are necessary for looming?
Yeah, typically temperature inversions right on top of water. Well,
No, that's for an inferior mirage. Can you try again, please?
what do you want? Like, if I'm wrong, tell me. What conditions? Do you
I
need?
just did.
Okay, tell me what conditions you need then. If I'm wrong.
No. You're telling us what you think will happen at 2,000 feet that you will not see looming. So you must know what looming is. But however, when I asked you what, okay, hold on.
Travis. Hold on, Travis.
Hold on.
Hold on, Travis. You're doing.
Hold on. Shut up, Laurie. Shut up, Laurie. Shut up. Okay.
I'm shutting up.
I asked you what conditions were necessary for looming, and you described the conditions for an inferior mirage.
Okay. If I'm incorrect,
So
then
you
correct.
I just
Okay, so
did.
what
Okay, my
conditions?
second
Hey, so what
question-
conditions
Why
are
are you
required?
arguing with people if you don't know what
No,
conditions
no,
they
he didn't tell me
or
what it
things
actually
could
was.
happen?
I think that it's temperature inversion. If I'm wrong, tell me what the right answer is.
It's not temperature inversion.
Okay, so what is it?
It's just well, I
Oh,
can show you
no.
I can show you a picture if you like of the temperature
Okay,
profile.
so what is
required.
You're out,
All right,
RC.
so what do you need
Rumpus'
for
turn.
mirage?
You're
Hey,
done.
hey, guys, if I'm wrong about something, then I want to learn the right thing.
No,
Yeah, when you have temperature inversion, you get mirages. That doesn't cause looming.
Okay.
Well, sorry. Sorry. Actually, hold on. Sorry. Let me just actually. No, sorry. Sorry. I'm gonna. I may have just made
Googling.
Are you gonna draw the diagram?
prematurely.
So I was under the impression that temperature inversions can cause miraging. If I'm wrong, tell
No,
me that I'm wrong.
No,
and
actually, no. You were right the first time. Sorry, you were right the first time. RC. I was. I can actually show you
Yeah,
the.
Say you were wrong, Rumpus.
I may have misspoken. Hold on, let me just check.
All right.
That's as close as it's gonna
The trick
get.
is I've corrected. If I have made a mistake, I've corrected myself, not due to anybody else.
Looming is
Oh,
due
right,
to
right.
temperature inversion.
All right.
Temperature inversion.
By the way, what Travis was trying to do was sort of a cowardly move. Trying to get your opponent on something that they don't know doesn't necessarily mean that they are wrong and they have no room to be in the debate.
Right.
Okay,
That's
so
a
when we
cowardly
look
move.
at the horizon, hold on,
my
real
question
quick.
is-
When we look at the
my
horizon,
question
hold
is,
on, RC.
why do
When
we
we look
see-
at hold on, RC. When we look
Why
at the
does it seem like-
horizon, hold on a second. I haven't spoke the whole show basically. Now, when we look at the horizon from 2,000 feet up, could temperature inversions be happening?
You're not going to see the effects of them because you're actually in a layer where those refractive effects aren't going to reach you.
What? Are temperature inversions happening when you're looking at the horizon sometimes from 2,000 feet up?
Not from 2,000 feet up, no.
No, there's never a temperature inversion anywhere near the horizon. So there's never a temperature inversion near the
irrelevant.
horizon.
When you have to get the effect you're looking for, you have to be going, the light has to be traveling through this temperature inversion or whatever for some distance. It's not as though if it's just a little bit of temperature inversion, you just happen to touch. Yeah, you need refraction. Yeah, remember that air is only very slightly refractive, so it has to run a long way. You have to be looking through a lot of air before it has a worthwhile effect.
You need a boundary, though.
No, you don't need a boundary. No, you see, you're just
what kind of refraction are you guys using? What kind of refraction is this?
No,
refraction.
The fact that I know you're about
formula. Let's get the formula up.
Right, no, it's nothing to do with Snell's law. You're just repeating QE nonsense who doesn't understand anything about atmospheric refraction.
Calm it down.
He's an utter moron.
Can we get back to my question, please? Can we get back to my question?
Yes, sorry.
Can I please get back to my question?
Yes, I'm going to show you.
So my question is, people, why are we taking? Why is there so much variation at 1 to 5 feet, and why are you ignoring observations from 2,000 feet?
Yeah, well, they're claiming to get the same effect, aren't they? I mean, we've got Brandon and saying here there's no evidence that you don't get the same effects at higher.
You haven't even shown us a single observation. I don't even know what the fuck RC's talking about.
Right. Hold on. Can I have a go? Repeating what he's absolutely correct in what he's saying. All the
it may be
things,
correct, but he hasn't, shown us.
I'm about to just describe
what he's talking about.
Hold. Be quiet. Be quiet. If you listen, you'll understand.
Already, it's been described.
Be quiet. Be quiet.
Now we want
Be quiet. You haven't understood what RC said. You haven't understood what RC said.
It doesn't matter.
All of the effects resulting in be quiet, you twat. You can
all right, let him go. Let's hear it. Let's hear it.
Jesus Christ. Right.
Go ahead.
You get all these strange effects. So, for instance, the one that I've got on screen at the moment, the one that I'm sharing, is the is actually what RC was correct when he said is a temperature inversion. I was as I said, I spoke very briefly and then corrected myself.
Graph that you're showing
he was correct. So here, for instance, is the temperature gradient of looming.
You're showing us a graph. You're not showing us an observation. You're showing us a graph. Just
yes, yes, because we've got to explain to you what causes it. And I'm showing you.
You show us the fucking world.
I'm showing. So we can just show you a picture of the black swan. This is a black swan.
And then you have to show us how you came up with these fucking numbers.
I'm showing you a picture. I'm not showing you the temperature gradient. This is a black swan type temperature gradient. Okay, so if you want to look at a picture, go and look at the black swan while I explain what's going on. Okay. So this is a black swan. Jesus Christ, can I finish? Stop interrupting me. So this is a black swan type profile. And as RC correctly said, and Brenda also repeated it, it is actually what you generally achieve by a temperature inversion. That means near the surface, for instance, this is from the Isle of Man.
This is all bullshit. Everything you're saying.
Can I just finish? Give me 30 seconds. Jesus Christ.
Rumpus.
Bloody hell. Brandon, can I just have 30 seconds?
Yeah, relax, man.
Be quiet. Be quiet, twat. You don't know what you're talking about. So this is the situation for the black swan. This sort of profile would give you a black swan. That is, you have a cool temperature at the thing, and then you have a temperature inversion. It's, oh, Jesus. So then it increases and then it decreases because normally as you go up, it normally decreases. But in the black swan type environment, it actually increases. It goes up for a brief period up to about 40 meters. And then it follows the usual course. And that's what causes this K value. This is the actual what causes the refraction. Oh, my God.
There it is. There's the K value.
Yeah, there's the K value. And that only happens at low altitudes. It does not happen when you're looking at 2,000 feet. Oh, I give up. Fuck off.
All right,
your sun is there. So when we look at the sun and they say it's not there, so it really is there. So you're contradicting.
So here's my.
Why don't we see RC Micey? Why don't we see curvature?
Can I make a point that I'm going to go? I'll make a point that I'm going to go. Here's my point: is that you like to take measurements from 1 to 5 feet, but if you take 25 more measurements from 100 feet to 200 feet or 500 feet to 1,000 feet, you're going to get incredibly precise much more precise than 1 to 5 feet. When you
We
can
don't
start
get
comparing-
curvature at any height, bro. We get no curvature
Never.
at any height.
Never seen curvature.
Y'all talking
If
all
you
this
keep saying
refraction
so.
bullshit.
What curvature?
Show
What curvature
us
are you talking
curvature.
about?
Don't
What
talk about
curvature are you
refraction.
talking about?
Earth curvature.
Any
Never seen
Earth
it.
curvature,
Not
you're
one
a
Of
time.
course you do. Yeah, whenever you're high
No.
up, you don't see ships
Never.
still disappear over the horizon. What are you talking about?
That's not curvature.
It is curvature. It's
It's
exactly.
curvature.
You don't see
It's
ships
caused
No,
by
it's
curvature.
not. You just
No,
say
that's
it's
your- that's your
curvature.
circle
Every
of-
time you see a
that's your
mountain or
circle of
something
sight,
obscured, that's
appearing-
There's
caused by
still.
curvature.
Can you
Nope.
believe this? Their go-to argument is still ships over the horizon. I cannot fucking.
Well, it's a
believe
great
it.
argument. It can't happen on a flat
Terrible.
Earth. It's a brilliant
So
argument.
crazy.
There is no
For
good
mountains.
counter argument for that.
Yeah, you
Oh,
haven't
there's
got an
so
explanation
many, and
for
we've
it.
presented them
There are
so
none
many
whatsoever.
times.
None. Zero. Zilch.
Then you're a
Absolutely
liar
none.
if you say that.
Talking
You're
about-
No,
just
offer
a
one then.
flat out
Okay, offer one
fucking
then.
science-denying liar. Then
Offer a single explanation for losing 2,000 feet of a
Rumpus,
mountain in the
is
distance.
the horizon Earth curvature?
how far
Rumpus?
away is the mountain?
It's caused by Earth curvature.
How far away is the mountain?
When people have quizzed you, when someone like Tim Osman was saying it wasn't Earth curvature, and we everybody went, pardon, Nathan Oakley keeps on repeating this. There's a
How
case
far
of
away?
what's the cause and effect. Earth curvature is this 8 inches per mile squared. That's the Earth curvature. Actually, it's a bit more complicated
No,
than that,
it's
but
not.
that's
It's
fundamentally
zero.
what it is, and that causes the horizon. The horizon is a
No, it
straight line
doesn't.
going left to right. That is not the same as
No,
Earth. It's
just a bunch of
caused by Earth
bullshit you just
curvature.
said. How far away is
No,
the
you just don't
mountain that
understand
you
what you're talking
said 2,000 feet of is blocked? How far away is it?
Well, it depends on the situation. That you can have a 2,000
Pretty
foot.
far
you
away,
could
right?
Easily,
Probably,
we have
what,
many
80
images
miles,
of
50 miles,
2,000 odd
what?
feet of a mountain
So
disappearing.
you just made
hidden
something
by
up.
Earth
You just made
curvature.
something up there. You know what?
No,
I'll
I
tell
didn't.
you.
No, I didn't.
I'll
What
tell
have I
you
made
what's
up? What have I
blocking
made
it.
up? What have I
I'll
made
tell
up?
you what.
What
I'll
have I
tell
made
you
up?
what. I'll tell you
What
what's
have I made
blocking
up?
it. Refraction.
What have
The
I made
atmosphere
up?
is blocking it. That's what's blocking it.
Bollocks! So we can see the sea
Well,
in the way.
we
for
have
instance,
we have
right?
observations of the atmosphere blocking objects that are on the surface.
Yeah, but that doesn't account for 2,000 feet. Well, we know little
Sure, it
infrared
does.
mirages
It's
can
further
block.
away.
It can block just a few degrees, but we're
No, it
missing
can't.
many degrees.
I
Infrared
don't give a
mirages
shit
can
about
only
your
account
degrees.
for
It can
very
block
small
2,000
amounts.
feet
You're just
easily.
referring to that garage issue. That can
Just
only
depends
be
on
the
how far
cause
away
of
it is.
very, very small angles of missing. And we can see mountains that are missing half of them. Well, they're occupying.
that's
we're
because they're
occupying
very far
5
away.
degrees. We can see mountains that are missing 5 degrees or
That's
something.
because
whereas
they're
the
very
infrared
far
mirage
away.
can only be obscuring fractions of a degree. You're
No, they
utterly
can't.
wrong.
No, I'm not.
Distance.
You're
doesn't-
utterly
We're
wrong.
not looking for
Prove that there's
obstruction. We're
curvature.
looking for Earth curvature,
distance
not
doesn't
obstruction.
obscure
Rumpus.
things.
He's
How
not
do you
wrong.
account for the fact that
Rumpus,
sea,
he's
if
not
what you're
fucking
if the
wrong. What's wrong with
infrared is
you?
causing it, we can see that the sea is there. We can see the sea, so it cannot be
Rumpus.
atmospheric obstruction because we can see
Rumpus.
the horizon.
We have proven
You know,
7
what
ways
can you
from
be?
Sunday
Not the.
that obstruction
not a physical
varies
horizon.
day to day, observation to observation. We want to see curvature, not fucking obstruction.
So
What do you
no,
what do you want to see? When you say you want to see curvature, what do you mean by that? You mean left to right curvature? Is that what you're talking
Curvature.
about?
We want to see Earth curvature, Rumpus.
That's what you see.
wanna
That's
see
what
a
you'd
measurement.
expect to see.
We want
Well,
to see your measurement of Earth curvature. We can walk you through it.
What
Can
do you
I
want
show
to
you
see? What would you
how it's
expect to
debunked?
see? Hold on. If you accept the globe model, what do you think you would see visually? Because what you would see visually,
I would-
visually,
I would-
is what we
Hold on,
do
let me answer,
see.
let me
We'd have
answer,
to
guys.
start with a consistent geometric horizon. That's where we would have
Let
to
me
start.
answer
Well, that's
real
good.
quick,
Refraction's
real
going to
quick,
screw
real quick.
that.
Hold
We
on.
know refraction exists, so you're not going to
Let
get
me answer
consistent
this,
geometric
Rumpus.
horizon. What a
Rumpus,
stupid
if you
question.
go to Google Earth, Rumpus, if you go to Google Earth, when you go from actual view to satellite view, it's a simulation of what the Earth would look like if it was a globe. And you see curvature, left to right and everything else. That's what we
Well, it's
would
left to
expect
right
see.
curvature you're
Let
interested
me
in.
finish, man. That's what we would expect to see if the Earth was a globe, is that globe projection when it turns into a cartoon. Yet we do
It
not
does.
see that in reality.
Because
Your
the
globe
Google
is
Earth looks
gone.
exactly like it does when we see, except for the fact it doesn't
No, it
account for
doesn't.
refraction.
No,
Yes,
it doesn't. Because
does.
you just said there's no left to right curvature. You always say you can't see
I
left to
didn't
right
say
curvature.
that. I didn't
I bet
say
you
that,
will.
but it's very
I bet
difficult
you
to
will.
see in taking a picture.
Of course,
Because
it's
when
difficult
you
to
want
see. That's
zoom
because
in-
it's
oh
not
my
there.
God. Listen,
No, I don't need to. I've heard it all before.
Listen, you haven't understood it then.
Show us some fucking evidence of Earth
You haven't
curve.
understood it, and I'll explain to you why.
I have understood it. Show us some fucking evidence of Earth
because
curve.
you wouldn't have made the statement you just did.
Show us evidence.
I'm about to
there's
explain why you don't get
the
left to right
surface
curvature
of the
obvious, and
Earth.
why you do get it along the line of sight. You get it
You're
along
gonna tell
the
us
line
why
of sight
there's
because
no
you can,
curvature.
oh my
Okay.
God, you just don't like the facts being, do you?
Go
When
ahead.
you're looking along the line, you see, you just don't like it, do you? When I'm giving you evidence, you don't want to hear it.
You haven't provided a single lick of evidence.
I'm about to, but you're not.
You're about to give me some more rhetoric.
I'm about to give you some evidence and some reasons why you don't see left to right curvature.
Rhetoric.
So evidently, no, you're not. We haven't let me finish. Right. So when you're looking, you see, every time I'm being interrupted. When you're looking along the line of sight, so let's say you're looking just something 200 miles away, which you can do if you go up a few thousand feet. So then you're looking along, and then take a camera, you zoom in, you can see along 200 miles worth of air and atmosphere and curve, and that's why you're missing half a mountain or something. Or the Blackpool thing, you only need to be seeing a couple hundred miles. But if you want to see left to right curvature, you need to have the same distance. You need to be able to see, say, 200 or 300 miles. But if you do that left to right, and you have to zoom back, you have to use a wide angle lens, the drop that you would see as a fraction of the distance you're looking along. So you're looking 200 miles long, but the drop would only be a couple of miles. So the ratio of those two is always going to be difficult to see. That's why you can generally only see curvature conveniently.
Are you done with your rhetoric?
It's a simple
Wrap
geometric.
Allow me.
You don't understand geometry. Okay, you're not interested in geometry. Okay, you're
Show some fucking evidence. That's what I'm interested in.
Okay,
I'm interested in evidence. Evidence.
Yes.
Okay, I got evidence right here.
We do.
Here's
We have
evidence.
evidence. Mountains are missing half their size.
That's not evidence of Earth curve.
What do you mean that's not evidence? That's exactly what we'd expect to see on a globe. That's exactly what we'd expect from curvature.
Go ahead, Brian.
And you deny it.
Rumpus, I'm about to present evidence of a plane flying over the Gulf of Mexico, seeing past Lake Okeechobee. He's 100 miles off the coast of Florida, seeing 300 miles or 400 miles to the other coast of Florida and far out into the Atlantic Ocean. So from the Gulf Coast of Mexico.
Oh, I can't see this. We can't see what you're talking. We can't see what you're doing, Brian.
You said you're about to present.
Brian, you said you were presenting something. I can't see anything.
I'm about to. But listen, from 28,000 feet, I believe it's either 28 or 31,000 feet, Jay Tolan Media from the Gulf of Mexico, an infrared shot all the way to Florida, all the way across Florida, all the way out into the Atlantic Ocean. 500 plus miles.
Jay Tolan known to falsify.
Okay, wait. You say there's no looming. You say there's no looming, but you're going to have to say fucking looming to explain this. Observation.
Well, actually, you get what you do get when you're up high. Let's say 2,000 feet. We're talking about. You do still get some refraction. It's not as much as standard refraction because oh my God, just listen. But it's not as much as say standard refraction. It's certainly nothing like the black swan.
Just
but you
hundreds
still,
of miles.
oh my God, Brian, just let me finish a sentence. So just pointing out, you do still get some refraction, but it's nothing like as big as standard refraction and nowhere near black swan refraction. So it's not a significant effect when you're high up.
Nice claims.
Brian, is it the one that Carnivore just posted? Is that the one you're thinking of, Brian?
Carnival's just put. Yes, he's just posted.
What's that?
Hasn't he?
What are you talking about?
Is the picture you're thinking of the one that Carnivore just posted in chat?
Is it Jay Tolan Medium?
It's date
26th of June, 2018.
Yeah, he's seeing from the Gulf of Mexico. He's seeing
you can
all
see
the way to Florida. He's seeing all the way across Florida, all the way out in the Atlantic Ocean.
Yeah, the picture has curvature in it.
Yeah.
No, it doesn't.
No,
There's a circle of light over a flat line.
Now we're talking.
This picture
Show us curved.
Circle of light over a flat plane.
Yes, curved. Yeah, exactly like what
me and Brandon did a little.
How is he identifying how far? As I understand it, he's claimed to be able to see all the way to Michigan or something on one occasion. It turned out to be completely in error. So how is he so? If this is the picture, hold on. If this is the picture, Brian, could you please tell me which bits identifiably bits of Florida, so we can find out exactly what we're looking at? How has he done that?
Hold on, man. Hold on.
That photo looks like the desert. That does not look like Florida.
Well, I thought you had the picture. We'll go with your picture, Brian. You offer the picture.
Well, let's see him. Let's wait till he brings it up.
Yeah, I'm gonna post it. I'm gonna post it. Hold on. I'll go get it right now.
Which picture do you want to talk about? The one that Carnival's posted from Jay Tolan, or are you going to post one?
He said he's got
me and Brandon did a little thing observation with the circle of sight, and as you go up, it does appear to start curving downward.
Sight. What's a circle of sight?
It's how far
Well,
you can see.
go get your phone out,
There's
and go look at your weather app. Okay, do you have a weather app on your phone? Go look at your weather app. Here's one way you can see it. And it'll have a visibility number, and it'll say like 10 miles, 15 miles. That's as far as you can see through the atmosphere at your location. That's your visibility. That'd give you a circle of sight. That's just what we called it. Understand?
Right. So
if you were to stand in a single spot,
let's call it visibility, because even if the visibility is low, I can still see things like the moon.
Okay, and on Earth you'll see in a circle.
Yeah, just where the horizon is. The distance to the horizon is really all you're saying.
That's all we're talking about is the ground, right?
Yeah, so distance to the horizon. That's all you're really saying.
How much ground you can see?
Well,
no, I'm not talking about the distance to the horizon. I guess you can consider it the horizon, but when you're in a fog bank and you can only see so far.
Oh, well, let's forget about fog. Horizon? Why you bring up fog banks?
I'm just asking. Would you consider that the horizon?
No. But let's not confuse the issue by talking about fog.
It's not confusing the issue. It's not.
It is confusing the issue. If we just talk about on a clear day how far you'll be able to see, humidity? That makes it a lot clearer than if we start talking about fog and God knows what else and rain. That's a complete. That doesn't affect any of the issues at all. It's just an obfuscation tactic.
No, it's not. The air has humidity, right?
You're saying atmospheric turbidity has nothing to do with how far we can see. That's fucking ridiculous.
No, I'm not saying that. I'm not saying.
That's saying it sounds like that's what you're saying.
Yeah, because you are not listening to me, Jeremy. That is an obfuscation attempt to confuse issue of the distance you can see to the horizon.
I'm trying to explain a concept to you.
We're not talking about the
humidity.
Well, it's an irrelevant concept then, because we're not interested about fog and rain. We're interested to how far you can see on a clear day.
What makes fog?
And that's determined by Earth curvature and atmospheric
What makes
refraction.
fog, asshole? What creates fog?
We don't care. We don't care.
I do. That's why I'm asking about it.
Geometry of the Earth. It's not relevant to this discussion.
See, they don't care about anything except there's curve, there's curve, there's curve, there's curve. That's all you care about,
You're just trying to
You're just hugging that ball tight.
You're just trying to bring up irrelevant red herrings in a desperate attempt to derail the debate about geometry. You don't want to talk about the geometry.
We haven't been having a debate about geometry.
Trying to give you
You don't want to talk about the geometry. You want to bring up anything else besides that.
We haven't had a debate about geometry.
Talk about geometry.
We have.
Okay?
I explained.
Now, let's do the math to your horizon, Rumpus. I just posted a video. Okay, let's do the fucking math together. On here, so you'll shut the fuck up. Okay, now let's check his altitude. The video's on. Okay, and I'll even give you the bonus. We'll say he's only seeing 50 miles out into the Atlantic Ocean, although he's obviously seeing way fucking further.
Well, hold on, you can't just guess. We need to know how far he's seeing out. You said it was established.
In fact, I'll go 0 miles out into the Atlantic. I'll give you the benefit. Your geometry is broke, sir. You understand?
I understand you don't understand what you're talking about. That's the only thing I understand. I don't know what point you're trying to make now.
We'll do it together from his right.
What point do you want to make?
Horizon and infrared, and it will not match your globe.
Okay, you got show me.
He does it for us.
Right. So what part of this video do you want me to look at? What timestamp?
I put it in general.
I'm seeing it here. What timestamp do you want me to have a look at, or do you want me to look at the whole video for 23 minutes of it?
Check the height. I'll do Google Maps and
which particular frame are you interested in, Brian? Which frame do you want us to discuss?
Go watch the whole video and come back.
Go toward the end.
Why can't we just look at a particular frame?
Go toward the end when he's closer. Toward the end when he's.
Give me a timestamp, Brian. Tell me which time. Give me a timestamp you want us to discuss.
1 minute from the end. One minute from the end when he's close to Louisiana.
22:45.
So 22. So 22.
45.
I know 22 minutes. Then how about that? So you want us to discuss what's going on at 22 minutes? Okay. So let's have a look at this.
Yeah, what I wanted to do is pick his furthest point from Florida because he gets close to Louisiana and he can still see Florida, which he shouldn't, and he can still see across Florida. Okay, this makes the globe, if you do the math, this makes your globe radius like. Here, I'll just let you do it. It's a joke.
Okay, well, I'm now looking at 22 minutes, and I'll see what. I mean, I don't know if someone else will be playing it so that the people on the viewers can see us as well. So I'm playing it at 22 minutes.
That top 1.69, is that the horizon, Rumpus?
I don't know.
I don't know. what
Yeah, I
that
don't know what
is.
this is. Indeed.
You probably have to listen to it to know what it is.
I'm listening to it as well.
That looks flat as fuck to me, I'll tell you that.
Well, it looks curved to me, left to right even.
I see that the land is sort of curved, and
Yeah,
the
that's it.
horizon does
There you
look
go.
sort of curved. Yeah, but that's like we said, that's the limit of your sight.
No,
That's
it's
going to
not.
create
That's
that.
the curvature of the
It
Earth.
is.
See the horizon out of both
The limit
windows.
of your
No,
sight.
that is going to create
It
the
can't
same
be
thing. You need
curving
to
left
prove
to
there's
right.
curvature.
Yeah, he wouldn't see the horizon out of both windows. Okay, when you're in an airplane, you see the horizon out of both windows. It ain't the fucking horizon curving left to right, dingbat.
No, hold on.
Well, also, even if you did go up on a flat plane, your circle of sight would make it appear that it was curving downwards on the edges.
Yeah, there's no such thing as circle of sight.
Yeah, we just explained it to you, and you agreed that yeah, there is such thing as visibility. So we're good now.
This is infrared. This is infrared, which would eliminate that.
Oh, really? Infrared? Hold on a minute. Let me address this. So, are you saying that infrared is some kind of magical camera that unbends the light and distortion from hundreds of miles away? That's a fucking amazing.
Through haze. That's what you're talking about. with the circle-
Really? Can it see behind hills and inside houses?
Not behind them. No, you can go through cloud. I mean, well, Brandon, you're being particularly
Does it
stupid today.
unbend light and put it back where it
No,
came
no
from?
one's claiming it does.
That's what
Where did
Brenda's
you get
saying.
the idea we're claiming that?
Well,
you can
think
just
about
see
it
through
for a
clouds.
minute.
So we're
All it
eliminating
does
your
is make it less
idiotic
hazy,
claims
right? It
about
just
bloody.
filters out some of the light spectrum, correct?
Yes, you're looking in the infrared, so you're looking in the spectrum. It's not affected so much by cloud and rain, which is
So
the
it's
thing
still
you brought up
affected.
for some reason. No one understands why you think that's relevant.
Brenda brought that up.
When we talk about
and,
the geometry of the Earth, and this
that
eliminates
somehow
that as
the
an issue.
infrared would cancel that out. That's which
Doesn't
is
cancel
really
anything
dumb.
out. It just simply
That's what
means
Brenda
you can
thinks.
see through cloud. Why
You can't
are you
see
having
through
a problem with this
clouds.
concept?
You can't see
You
through
can
clouds.
see through
these
cloud
clouds up
with
here?
infrared. Jesus Christ!
Do you see these clouds up at the top of this the
Well,
frame here? See
it
these
can
clouds?
it can
Why
get
aren't I
through-
seeing
it can
through
get
these
through
clouds
more.
here?
It can get through a certain amount.
Oh, but it can't see through clouds. A minute ago you said it can see through clouds.
Well,
and
the
I
trouble
see
is, I'm having
clouds.
to use simple words to you because you're having such a problem understanding. You seem to think
No,
we're claiming the
because
infrared
you're a
means you're unbending it.
bullshitter
We've
and
never
you're
said such
talking
a
out
thing.
your ass.
No,
so
you're
you say
talking
fucked
out your
up
ass.
things.
Jesus Christ! You don't. You seem to be claiming that. I mean, why you bring up fog and rain? No one knows. It's utterly irrelevant.
So
to
humidity in the
geometry
air
argument.
doesn't impact visibility.
Yes, we don't care about the case when it's foggy
Of course
and rainy.
you
That
don't
doesn't
care
help.
about it. All you care about is Earth curvature.
My God. Yes, and we can only see that when it's clear. If you, I mean, we don't talk about you being in your bedroom with the doors closed either.
It's
being able to
never
see it.
clear at
That's
long
just as relevant.
distances.
It's just
It's
as relevant.
never
you saying you're in a
clear.
box.
Rumpus.
I mean, what?
Seriously, you're not
utterly
good at
irrelevant
this.
debate. I mean,
Near
my
the
God.
horizon, it is never clear.
Maybe let
Clear
our
enough.
take back over.
It's clear enough. We can see where the horizon is if it's a nice clear day. Simple as that. That's all we need.
No, Rumpus,
Yes.
you're wrong. No.
You're saying we can't see clearly defined
Do you
horizons.
see the
when we're up
horizon in
an
this picture?
airplane.
Do you think we see a clear horizon in this
what's
picture
your
here?
distance? What distance are you talking about? That you can see a clear, crisp horizon.
Well, it depends on the weather conditions, but you can generally. I mean, obviously, once
Now
you
it
start
depends
to
on
go
the
up
weather.
to.
Yo, is this guy from New
Yes,
York?
so you
Is
don't
that Lake
include that as a
George?
factor.
Are you kidding me?
Why are
You just
bringing
told
this
me we're not
confounding
worried about
variable?
rain or anything. Now you're
Oh
saying
my
that it
God.
depends on the weather.
Hold on, is
I'm
this Lake
saying
George from New
how
York?
far. The question I was asked: how far is the horizon? That does depend on the weather, but you
I did
avoid.
not say,
You do
I
not
did
include
not
that.
say how far is the horizon. You said the horizon is crisp and clear and easy to define.
On a clear day, yes. In other
So
words, you
that
can see. There are situations when you can see a well-defined horizon at a few thousand feet up. Yes.
Yo, is that Lake George in New York? The picture we're looking at?
When you talk in generalities like that, then
Florida.
it just leaves it open for anything to
alright.
be.
But I don't understand what you seem to have problems in reducing the issues you have to concern yourself with. When we're talking about the geometry of Earth, which is the discussion we're having, you don't want to bring in things like the rain and fog, which are going to confuse how far you can see in the because seeing the horizon is part of a
We're
consequence of the
talking
geometry
about
of the Earth.
reality, and anything that confuses our ability to see the geometry and reality is pertinent to the discussion.
So we
This is
pick
like
on
very
days and
simple.
situations where that's not relevant,
Show
like a
us
clear
one.
day.
Show us one where
We
you can
do
see
not-
the horizon hundreds of miles away and it's clear.
Well,
Yeah,
I mean,
seriously,
this...
Rumpus. Do you know how much atmospheric turbidity there is out there?
No, they're talking out their ass. They don't know what they're talking about.
Do you even know what atmospheric turbidity is, Rumpus?
But yes, but are you disputing you can see hundreds of miles to horizon? I mean, this is just an incredible line of argument. Jeremy is. He's saying
Hold him
basically
down,
you
make
can't
him
see
squirm.
horizon.
That's
He's saying
exactly what they are doing.
stability and all sorts of other crap. Which is, are you confusing what the horizon is? And that's what his point is making. It's absolutely ridiculous.
Do you ever have a crisp horizon when you're hundreds of miles away from it?
You can have a crisp enough one.
Show us.
Well,
yeah, fuck off. Yeah, you can't.
Science basically says Bowen and Fraser.
Claiming then. So what height are you claiming I can't see horizon? Crisp. Have any crisp horizons? Above what?
Above 1 mile.
A clear, crisp.
So do you concur with that, Travis? Are you saying that if you're 1 mile up, you can't get a crisp horizon?
Let's see.
Hold on. I'd like Travis to respond. He's making the claim. Travis,
would you like me to just pull it out my ass? I don't.
You made a claim. Well, you just said you can't see a crisp horizon when you're high up, and I'd like to know how high up you think you have to be before you lose the ability to have a crisp horizon.
Let's see. Well, when I want to know,
are you going to dodge that question?
Why are you guys talking?
Guys, hold on 1 second.
If you want me to answer. If you want me to answer according to my experience, I've been up in a plane, 35,000 feet. At that height, it's not a clear, crisp horizon.
I would like to know when does Earth start curving? When do we start seeing Earth curving?
Can I back it up first?
Jeremy, can I just respond to Travis's point? I would like just to respond to Travis's point. I'm next. Travis, but do you think it might not be perfectly crisp, but do you think you can establish where it is at, say, whenever you're in an airplane? You can establish within a few tenths of a degree.
That's not in question.
We're talking about where the horizon is. That's the question we're talking about now. And you're saying, well, it might not. I'm saying, okay, it might not be perfect like a crisp, thin line, but at least we can see where it is to a reasonable degree of accuracy. That's the important thing.
Changing the goalpost right now. Absolutely.
Yeah, big time.
But my point is relevant. We need to know where the horizon is to a reasonable degree of accuracy. Now, you're saying, I think what you're saying is it's not a pencil line, absolutely crisp, sharp thing, and therefore that's invalid. And that's because, again, flat is always working binary. They all say,
all right, Rumpus, shut up for a minute. You're just bullshitting right now. Go ahead, Jeremy.
Now, how high up do we need to go before we start seeing this Earth curve from left to right?
You can see it at ground level.
Get the fuck out. Ban him.
You moron.
Oh my God, come on, man.
You can see it, and if you've got a nice, for instance, on Oblivion Salt Flats, I mean, we know we talk about the Neil deGrasse Tyson claims you can have to go up to so many, but there are situations, for instance, there's some balloon footage at just 700 feet, and in fact, of course, we've got the Mallorcan guy who's got 700 feet, and he was able to demonstrate left to right curvature
at
just
total
700
nonsense.
Feet.
It was an iPhone 6 and it had moustache distortion.
No, it didn't, because the point is that the thing he had in the picture as well was perfect.
No, you reckon it was a rectilinear lens, and it wasn't. You're a blagger.
But
you're a liar.
moron, the thing he had in the picture was still straight. Therefore, it was not causing bending.
Nonsense.
So we do not need to consider.
All over the place.
We do not need to consider whether the lens.
He is a barman.
We've got a visual demonstration that it was not doing what you're claiming.
It was bending. The metal underneath it was bending.
No, the metal was not bending. He had several pictures where the metal was not bending, and
therefore,
oh my God.
Therefore, you know the lens was not.
I have the picture.
You therefore know the lens was not distorting it. This is simple logic. Gleam, how can you dispute
just show how
anyway, just to settle the other one, I've just tagged you up in general. It's Bowen Fraser in American Journal of Physics, 1986. At altitudes greater than a few kilometers, the horizon is indistinct because of contrast reduction. Even on extraordinarily clear days, an airline passenger flying over an ocean cannot point to the apparent boundary between the earth and sky and confidently proclaim its distance. To determine the distance to the horizon within 10% requires knowing its angular position within a few minutes of arc. This is unattainable in realistic atmosphere, even one that is very clean. Scattering by the air molecules themselves is not quite sufficient to blur the horizon, but it does not take many particles before the horizon becomes indistinct. and that's
Right,
Bowen
so
and
this
Fraser.
picture, so for instance, we've got some pictures that are being posted here by.
You agree
Jason.
with that or not, Rumpus?
No, I'm
Yeah,
not. Look,
Rumpus.
you can look at the picture.
You don't agree
No,
with
no,
that
no, no.
science,
You
that
respond to
mainstream
Gleam,
science.
Rumpus.
Yeah, I don't agree. We've got situations, pictures on screen now demonstrating that what I would regard as sharp. And you claimed just a moment, about 5 minutes ago,
No,
that
that's
if you were above a
scientists.
mile, hold on, you said 5 minutes ago that if you were
Yeah.
above a mile, you wouldn't get a distinct thing. Now
I
you're
was citing
using
this
capacity
paper.
in an aeroplane. Yeah, I
I
know.
was
Well,
citing
okay,
this paper.
so you're changing your mind. Are you now saying it's no longer a mile? It's still
You
incapable
think
of
this
being
is
distinct at a
this?
mile?
You
'Cause
think this
because
is
that's what
Chris?
you
It just
said
says
5 minutes
at
ago.
altitudes greater than a few kilometers. It says a mile in there. I get it from the David K. Lynch paper, which
Right.
says that you cannot see X to Y curvature anywhere below 14,000
Yeah, that one, that
feet.
paper. Yes, I'm familiar with that paper.
Yeah, and he says
Yes,
he
that was
uses
for-
this paper. He cites this paper and says you cannot see a distinct clear horizon above 1 mile in
Well,
that
we can
paper.
clearly see. I mean, it all depends what you define as distinct. We can clearly see some.
Well,
pictures
here's a
provided
picture
by-
you just
So
said
you
was
don't agree
distinct.
with
Let's take a
mainstream
look
science.
I'm saying that's.
So what fringe science do you
it
follow,
depends what, well,
Rumpus?
perhaps he's talking about during the day. We've got some evening pictures here of it being.
Shut
distinct, or
up,
perhaps-
Rumpus. Stop
No, so,
babbling.
no, be quiet. No, you right. Give me the link to that
babbling
paper.
nonsense,
which
mate.
no, you're spouting crap. Give me the link to that paper. And
I've
I will
cited it in general.
Given the fact that every single time you've ever cited a paper, including
No,
the ones
don't
about dark
babble on
matter,
with your
you
rhetoric.
never
It's
ever
bullshit.
get it right. You're always
Well,
contradicting
when the last
a
time I done that, you
paragraph.
said, "Oh, Gleam is in fact right. He is right. This effect does happen." That was your
No,
last
that
sentence
was
to
another
me.
issue.
Last
That
time I
was a- that was a
cited
slight-
one.
Almost all the things you ever cite, you
Almost
guarantee.
now it is, and it's going to change. It was all a minute ago.
99%.
Can you
of
stop
things
the
you ever
personal
cite,
attack and
well,
can we get on
occasionally
with
you
the
get it right.
science?
I mean, I don't deny occasionally you accidentally get things right, but 99% of the time you're wrong, and your
Accidentally
citations
get
are
things
invariably
right.
followed by the
That's
next
hilarious.
paragraph also invalidating you. And you cited papers where you only read the abstract, and then I come along with George, and we find out you
No,
don't
you
even
don't.
know the difference
You
between
make up
voltage and velocity.
lies, like you just
voltage-
did.
So, hold on. So you're claiming then when you cited that dark matter paper about gravitational
God, you're
issues,
dragging
Are we
up
done
this
with him?
again.
yeah, you're just
Are we
dragging up
done
the
with
facts
him?
where you didn't
Are you
even
distracting
know
from the fact that
paper.
I've just caught you out saying you
No,
do
you haven't
not
caught me
trust
out. Okay, give
mainstream
me this
science?
paper. I guarantee this paper
It's
will
in the
not
general
agree
chat.
with you.
It's in the general
right, which
chat.
paper? Okay, I guarantee.
I've
Go,
just
you
tagged
go
your
off
name
and
in
read
it.
that, Rumpus. Go read that.
I guarantee
He's
it'll
a panic
contradict you.
man. Look at how salty you are. You go through all of the past.
Rumpus,
Dark matter
real quick, guys. Rumpus.
We can see some
Rumpus,
pictures.
no,
Look,
hold on,
just
Rumpus,
look in the
Rumpus.
general chat, and Jason's
Rumpus, I'm
posting
talking,
pictures from
Rumpus.
an aeroplane
Rumpus,
that have
you're
distinct
overtalking me
horizons.
right now.
We can see visually that guy is wrong.
Rumpus, you're overtalking me. Listen,
Nonsense.
Listen, Rumpus, look. Can you chill the fuck out, right, and just have a decent paced conversation with people? Why'd you always make it so fast paced and so fucking,
Because
essentially
I tried
hectic?
earlier to
You're
speak for
making
10
the
seconds and I was
conversation
constantly
hectic.
interrupted.
Just
That's
chill
why
out.
I have to speak quickly so that I don't get interrupted every 10 seconds. So I
Right,
can
well,
get something
well,
across.
Rumpus,
If I was allowed to get
I
30
guar-
seconds
I
in a sentence,
guarantee,
I
Rumpus-
wouldn't have to speak quickly.
Rumpus,
Rubbish,
I
you had
guarantee
enough
if
time.
you just chill out for a second and talk slowly, I guarantee the moderators in this room will help you not get
You
interrupted.
can't guarantee anything.
No, I guarantee
I
it.
can't find this.
will
Where did
guarantee
you
it,
post it,
Rumpus.
Gleam? Oh, there we go. You
Hey,
finally posted
do
it.
it
Right.
again.
All right,
No,
let's
that's
move
the
on
Lynch
real quick
paper.
here because he's acting like he's got evidence of these crisp, clear horizons. Here's one. This is a picture from a plane. Here, this is supposed to be a clear, crisp horizon. Let's take a look at that horizon and see how clear. You guys see a clear, crisp horizon there?
You showing the right one?
I'm showing
No
one of
way,
them. You
that
said they
is-
were all examples, didn't you?
You are such a blagger, Rumpus, if you think that's crisp.
Where's the fucking
It's
horizon?
within. I'm going to argue something that's crisp is something less than. a
Stop
degree.
arguing. You've got no argument.
I have got an argument. You're just not interested in any logic. You
You're
can't-
looking at that and telling me that's a crisp horizon. You're an absolute knob.
Well, here we go. Brandon picks the wrong one.
Oh, of course. All right, Rumpus. You go read that. You message me when you're done. We're going to move on for now. All right? Thanks, buddy.
The wrong one
All
because
right.
it doesn't fit my narrative.
Anyway,
Okay,
good stuff, Gleam. I figured you were going to bring up that NASA paper. Let me read this real quick. Science of Science, 999. Rumpus's version of science is to ask you a question about his overactive imagination. He's got an overactive something. That's for sure.
Motherfucker needs ADHD medication or something. Adderall.
I just love how he comes on here and says, yes, I openly admit I disagree with science. And then puts it on me and says, oh no, it's because you've misunderstood it some way, shape or form. And I always point this out.
All the time, Gleam.
Absolute nonsense.
Yeah,
And you're
absolutely.
the
He also
same.
said this
You're
wasn't
the
bent,
same.
Gleam.
Another liar.
He said this was straight.
There
The
is-
steel was straight.
There is
I've
actually
cited the
sometimes
papers. It removes my personal bias. Read the papers and tell me where I got it wrong.
What's the next subject that we want to move on to?
I do have a good subject for us. I've got a picture that is really interesting. It was on the thumbnail if anybody saw it. Hopefully this will be a good conversation. Let me just transition it over. You guys should see it. I'm sharing my screen in Discord. You guys see it?
I'm still seeing the
I
Lake
still see
George.
Florida. I still see
Florida. What the fuck, man? Hold on, I'll bring it up. Give me 1 second here. It is from Salvador Dali. You guys are familiar with him? He's the guy who did all the
Never heard of him.
dripping watches. You've seen his work, trust me. So this is called Geopoliticus Man, I believe. Birth of a New Man. I've seen 2 titles. Maybe it's both. And it was done in around World War II, I believe. I'll look that up in a second. But just kind of take this picture in and look at this thing and see what you notice and what he was trying to get across with this painting here. What the fuck was he talking about?
I mean, it looks like they're trying to stretch that ball out or something.
There's a man. Here, let me point out a couple things here. There's a man who is halfway out of a crack in this globe that's shaped like an egg. He's got one hand out that he's grabbing on desperately, and he's got a foot out pushing out into the ocean. His head is concealed inside the egg globe. There is a veil that is levitating and draped over the earth egg. There's a woman whose private parts are covered by a leaf who is showing this sight to her child, who's obviously afraid of what he sees. There's a white sheet underneath the egg that appears to be shaped like Antarctica. There's a man here in the background. I don't know what he's doing. There's mountains in the background. There's an obelisk on the right-hand side. There's glaciers. These appear to be glaciers to me. What the fuck is this about?
I can help you. Where's the man? Where's the man erupting from?
Is he erupting?
North America. North America.
Is he coming?
His head,
North America.
His head
North America. Where is his right hand? Left hand. Left hand.
No, his head is in North America. His left hand is I don't know where his left hand is, but his other
It's in the
underneath.
ocean. I think maybe Great Britain.
It's Great Britain and the UK is talking about the emergence of America as a global superpower.
Yeah. I don't know. I think there's more to it than that because I've read that as well. Does anybody else have another interpretation of what they see here?
Most histories will tell you that America emerged as a superpower during World War II because of the vast investment by the government into infrastructure and the war effort. Prior to the time, we were an agricultural society, and after World War II, we were a major industrial society.
One thing that picture does show, it shows South America way further left toward Australia than Google, than the globe. Okay, and also I just seen I was watching what was it, Godzilla versus King Kong, and they showed a map, but they only showed half of it, and it was a flat Earth map, and it had Australia closer to South America. And then I got a point to make about the sun with Australia and my location after this topic. But you look at Australia. I mean, look at South America. It's closer to Australia than on a map.
It says actually the title is Child Watching the Birth of a New Man. That's another title I've seen it.
I get something from it. I get that it's got a much clearer horizon than Rumpus's citation.
But by the way, it was painted in 1943, so it was still during the war when it you know it very much wasn't decided when he painted this.
It also shows potato Earth.
It's an egg.
What's potato say, Precious?
It's a potato.
It's an egg.
It does look like an egg. Why is there a woman
there is also
pointing?
white and yolk.
Why is there a woman pointing and showing her child this man who's trapped in half in and half out of a globe?
I was just wondering. Right, barely north of Italy. What's barely north of Italy?
Somebody else was going to say something.
I was wondering whether she was pointing at the Middle East, but if you're saying North Italy, that's more.
No, that's not North
Bulgaria.
Italy. That is more Middle East.
Wait, ain't that boot Italy?
It is more Bulgaria. You are right. It is more Sofia. And
Oh, see, I took it as she's pointing at the man. She's going, "Hey, look!
Yeah,
look at them. What's happening to
she's
this
African,
man?"
I think. If you look close, she's African, so it depicts Eve basically saying, "Look at the big, massive Westerner taking over the world."
She's got light hair.
No.
Yeah, I don't think she's African. She doesn't look completely human to me, to be honest. Look at her ribs.
That's
and
how
her
he
breasts,
does.
how they're kind of high up.
She's
like
a
that.
giant. Hold on, she's a
And
giant.
her
That's
and her
Rumpus holding
muscles.
On to her, that's Rumpus holding onto her leg. She's a giant.
Look at her muscles and how muscular her legs and her arms are.
Yeah, that's how he draws figures.
Okay, Jesus Christ, you're just gonna shit on everything, Brenda?
I think she's
Well,
starved.
actually,
She is indeterminate gender because her right breast is masculine, her left breast is feminine.
No,
Notice
I
the
think this
dome
one's, she's got her arm held up, so this one's just drooping more. This one's kind of pulled over towards her armpit.
I was actually about to say earlier that I'm not sure.
What about blood on
her
her finger?
if that's a woman or not.
Sorry, man. Her finger's right
Oh,
by
it
a
might
body
not be
of
a
water,
woman,
though.
yeah.
Nah,
Why
he's
is there
got
an
this.
obelisk? Why the fuck is there an obelisk in the background? This thing.
Did anyone else point that out? The blood on Antarctica? What do you think that means?
And the
I know,
obelisk
right?
is on one side of the dome. The obelisk
It's
is
not a
on one
woman,
side of the
Brandon.
dome.
You can tell by the shoulders. They're always like.
No, there are red bleeding glaciers in Antarctica. If you've ever seen them, it's like there's some sort of oil or something leaking out of a side. Not man-made. It's all natural, but it's leaking out the side, and it looks like blood dripping out the side of a glacier. I'll have to look up.
I wonder if this is Antarctica underneath it, right? Does this have any symbolism connected to the North Pole, this veil? I took this as there's a veil.
Well,
the veil is
strangely,
set
the way
over the
you said
man
egg-
who's half in and half out of the earth.
Well, the way you said egg, I think both the white bits are the shell broken.
Oh, this down here? Oh, that's interesting.
Yeah, that's where my man, it in my mind actually connected to white.
Oh, I think you cut
South
out a little
America
Lori.
looks like it's touching Antarctica. South America is literally touching. It's folding up onto Antarctica, the tip of it. But it's showing the obelisk, which would be, I guess, the North Pole, on one side of the dome, and then maybe representing. And it's showing. Look at the clouds. They're showing the atmosphere get higher under the dome in the middle, which is what we experience in reality. The stratosphere is higher at the equator, and it drops down on either end.
Are you talking about this back here? This cloud?
Yeah, like the cloud, how it's dome shaped.
Okay. There's these guys in the background too. You can't really see them. It's kind of weird. Let me see if I can open it.
Yeah, Dali wasn't a flat earther.
Did I say he was a flat earther? Is that what you think I'm getting at?
Talking to Brian.
Oh, you don't know what he was though.
Everybody's a flat
Did you know
earther, Brenda.
Salvador Dali, or
Brenda.
did your parents know Salvador Dali or something?
Brenda, everybody's a flat earther, huh?
What is that about the egg, Brandon, on the left side, on the shadow? Is it like what is it like?
Where is that? Oh, on the picture.
Yeah, on the left side of the egg, on the shadow side. There's like a, I don't know. I see some figures, but I cannot make up what it is.
There's two figures, red and black.
No, no. I'm talking on the shadow of the egg. There's like
nothing.
some.
What?
You guys don't see it?
No.
Let me see.
I've never
here.
been much
on the
into art, man. I
shadow.
let other
Oh, right
I think
here.
they're just artifacts.
Above,
I think they're
above
just
his
little
feet.
white artifacts.
I think it's more
Oh, yeah, them
land.
little bits.
It's like
No,
the land.
Brandon,
That's...
it's on the egg, on the
Those are
shadow.
the red. Oh, that's
I
just.
got it. I got it, y'all. Look, I got it. It's showing the rise of America after World War II, and you see his globe. His head's a globe. So it's saying after World War II, the white man's emerging from victorious from North America, and they're globe heads.
What would you
Maybe,
do
man.
if it had a little peel away section and you opened it up and it was Nathan Thompson's face?
Oh, that'd be great. We should do that.
Oh my god!
There's a meme for somebody. All right, yeah, I thought I'd show you that. That's another cool picture that I actually had a poster of this. I found it at a garage sale for the longest time.
Yeah,
And I looked at it one day and I was like,
above the-
"What the fuck?"
There's a small figure above the lady's arm as well.
Oh yeah, this guy right here doing that. I don't think that there's a close up of that. No, there's not.
Yeah,
And-
that's one of the stick figures that he likes to
Doing
draw.
Tai Chi back then.
Oh, that's one of his things. It's like bending
No.
over or something.
I'm just blagging. I'm winging it as much as Brenda is. Let's all just pretend we know everything.
But would you guys say that?
I'm not
Would you guys say that he's trying to depict the sun as behind this? You know, in the foreground, in the background. Sorry.
No, because
Yeah.
the shadows. The
Yeah,
shadows
that's
are.
what I was going to say. Because the shadow would mean that it would be from behind the perspective that we see it.
Of the lady. That's the point I wanted to make about. I took a picture of the sun yesterday while Mitchell from Australia was live with his Flat Earth School, which I recommend everybody check out. Mitchell from Australia. And
wrong, Brian.
I recommend everybody check out Mitchell from Australia. But I went to SunCalc. It said 40. Well, you know what? I'll save this for after. But I like where he's going with the sun thing because that's my next point after this.
Yeah, but you got that wrong, Brian. We measured it. We measured it on the screen. It was about 45, 43 degrees. You were wrong.
Okay, well, when I had her pointing at it and I set the phone on the ground, okay, they would beg to differ. Okay, SunCalc does not match my location. I'm sorry to say.
Yes, it does. It does. That's the point. You could.
How can you measure on the screen, Brenda?
You put a protractor up to the screen.
Okay, you put a protractor up to somebody pointing over your head. Okay, so now
It's called trigonometry.
hold on. I stood 10 foot away from my 10-foot roof. I knew they were going to say that.
Anything.
Hold on. I stood 10 foot away from my 10-foot roof, and if I seen the sun just horizoning on the roof, that would have been 45 degrees. Okay, so
You didn't
that right there.
measure anything, though. You just eyeballed it.
Yeah, what is it? About 65 degrees?
No, it's
I had to
45.
point at it.
3. It's not 60 degrees. It's not 65. You're wrong.
Are we missing something? I don't know what the hell you guys are talking about.
Okay, I can explain it to you very quickly. Brian.
She's lying through her fucking teeth, dude. I don't appreciate it.
I'm not lying. So Brian did a video where he had his girlfriend pointing at the sun, and he
That's not my
claims-
girlfriend.
Well, I don't know. I just assumed that she was.
Stop
Well,
getting the
don't
facts
assume
wrong.
nothing.
Let him explain it then.
So the point is that she was pointing at the sun. You were claiming it was 60 to 70 degrees. It is not. You can measure it on the screen yourself. It's about 45, maybe 43 degrees, which is what is.
Once again, I've walked 10 foot away from my 10-foot roof. Okay. Now, if the sun was 45 degrees, It would have been right on the roof, Brenda. Okay, it's way above the roof. It's almost straight overhead, Brenda. I set the phone down on the driveway. Hold on. I had this girl point at the sun. Okay, I was like, "Hey, do me a favor, point at the sun real quick, Michelle." She pointed at the sun. Okay, and then I set the phone on my driveway flat to show that it was still in focus at the bottom of my screen. And then I showed what I think would be flat just by holding it. Okay, it's about 65 degrees. I said 60 to be safe. It might even be 70. It's almost dead overhead, Brenda.
It's not. It's not. Because you can measure the screen. Did you measure the angle of her arm on the screen? Did you measure it?
Anybody, okay, can go and look where she's pointing and see it's not 45 degrees. That's where goddamn
Did you measure it? Did you measure it, Brian?
Anybody wants to go to Flat Earth Test, it's the first 5 seconds of my video. If anybody wants to go to Flat Earth Test, it's the first 5 seconds of my video has the lady pointing at the sun.
About 45 degrees.
Will you agree, Brenda, that based on the angle where the picture was taken, it can give you a different reading other than what you think it can measure on the screen?
He didn't measure the angle of her arm, and he's claiming that the website that he looked up gives the incorrect result, and he never took a measurement.
It doesn't take a genius to see the sun is just offset from overhead. Okay, it happens here a lot. Okay, I set a pole out. I showed live on Jose's no shadow on a pole. Okay, and this was about a month and a half, 2 months ago. 0 shadow.
Brian, you didn't measure it.
Hey, listen, Brian, the only thing that you need to do is just repeat your observation. It's going to be a couple of days off, okay? But just do the same observation again and be a little bit more specific and see if you come up with the same
it was higher. It was even higher today, Travis.
Result.
Measure it.
Actually, but I started recording, man. I was a little bit busy, but it was a little higher today.
Shut up, Brenda.
Sun calc does not match my location. It's it does sometimes, but not very often.
Science of Science, $5. Brenda is basically saying around World War II is when the U.S. propaganda started. The globe is a symbol of the U.S. supporting science. Yeah, I obviously think that there's more symbology in that picture than, oh, it just means the U.S. became a superpower. I don't know what he was thinking about when he painted that, but it's got a lot of meaning for me when I look at it. It's a really interesting picture. Go check it out and see what you think.
The sun could be directly over my head or even a few degrees off from where I'm at in the time of year.
You have difficulty measuring shadows, we understand. But you didn't take a measurement here.
You can actually quite, at least my eye says that he's actually farther from the house than the roof is high. Like it's visually there in the video.
It might look like that. Look, well, her head looks like it's just almost the roof.
He just twists things to fit his narrative. That's all he does.
Brenda, you're
all right, let's move on.
Mouth,
just
dude.
repeat it, Brian. I mean, I get what you're saying, but yeah.
Ooh, that's a good one.
And listen, anybody who wants to see this, go to Flat Earth Test and look at the first 10 seconds of my video. It's only like 2 minutes long. It was a quick observation because I was like, damn, the sun's dead overhead and it's 4:30. Let's see what sun calc says. Every now and then I see the sun too high in the sky, so I just stop and take a video. Whoever's around, I have them point at the sun. And then I show shadows and shit. And I looked at sun calc. It said 43 degrees when the son of a bitch was about 70 degrees. I said 60 to be safe. Okay. And I'm right here at the same location. But anybody, yes. And then I compared it to Mitchell from Australia. So he was live. Okay. So anybody who's listening is not subscribed to Mitchell from Australia. He's good, man. He's good at debating. Hopefully we'll get him on this show one time, but subscribe to him and check out my video, man. It's hard to argue. I don't know exactly the angle of the sun, but you can see her pointing in the first 10 seconds of it. It's not 45 degrees. That's a damn lie.
If you don't take a measurement, it's worthless.
Brian, how'd you set up your stick to be vertical? Did you just place it in the ground?
No, I had a level. Okay, I just did a spirit level on 2 sides, on 3 sides. Actually, when I did that video, that's before I got the spirit level, but I checked it and it was damn close. And I corrected it after that. And I haven't seen a day with the sun directly overhead. Like, that was the strangest looking day, dude. The atmosphere was so clear. I mean, it was the weirdest day. It made me even look up like that. It was hot as shit all of a sudden, dude. And it was real clear, and the atmosphere just felt weird, man. And I look up, the sun's like right overhead. I look at a basketball, and there's zero shadow. And by the time I got the camera, there was like a tiny, teeny bit of shadow. But listen, I'm 31 degrees north, and this was 2 months ago. So this was off by, whatever you want to say, no matter what, 5, 6 degrees. But man, I think it's more like off by about 15 degrees. But it varies here, man. Call it whatever you want, refraction, who knows? But it doesn't always match with sun count.
Well, I call it you not knowing how to measure shadows.
Now, I'm right
What's
here.
your channel name again? Sorry,
I can
Brian.
put it on video. I'll pull a tape measure 10 foot off my house, okay? If anybody wants to see where I was at, okay, I'll put the video on live. I got to put some pants on. And I'll pull a tape measure off my house 10 foot.
Yes, please do this with pants on, please.
To show her she's how far away I was from my house. Maybe not the whole video. I might not have been 10 feet. But from that one point where I set the phone down on the ground, that was 10 feet away.
So, what's your conclusion, Brian? You think that the timeanddate.com has the wrong sun angle based on your observation, or what?
It's off a little bit. No matter what, it's off somewhat. Okay, but some days it's off by quite a bit. But here's my point. Okay, I'm on the east coast of the United States. If the sun was, appears to be about 70 degrees. Let's just call it 60 degrees. Okay,
let's call it 43, which is what it was.
Mitchell from Australia had his sun in Australia over the horizon. There's no way. And so that gives me 2 points. One, that could never work on a globe. I set up a spotlight, but I've shown that enough times. I didn't have to put that in the video, but I put the spotlight on the globe. It does not work on the globe. But more importantly, on my flat Earth model, the sun shines about 6,200 miles. Okay, so if it's over my head and on Mitchell's horizon, then Australia is not as far away as we have been told. Our map. No, the point is Australia is not as far away as we've been told, because the sun over my head are even 45 degrees, and on Mitchell in Australia's horizon puts the sun way closer to South America than the 13,000 miles they claim on with having to go from Sydney to so we got to fix this map, and I think we could do it with suns, but it's going to take a concerted effort of a bunch of us. But
why don't you take measurements? Why don't you take measurements of the heading in which the sun is? Like at the same time, get on Discord and just talk at the same time. Say, hey, right now, take the measurements. Get the heading value as well as the angular, the angle to the sun for each of you at the same time. Why don't y'all do that?
All right, Jeremy, are you interested in putting something like that together, Jeremy? With one day with sun observations, as far as like we could center it around Mitchell, because he's going to be out there every morning showing the sunrise, and then we could go from there. We could just start with Mitchell since we know he's there, and I could talk to him. And if anybody wants to join in this, let's do this. Because that would show the sun can't be that far away if it's even anywhere near 50 degrees or 60 degrees over my head in Florida, and on Mitchell's horizon. You feel me?
Right, really high for you, really low for him. Strange, but yeah, it would be awesome if some measurements were taken, especially if you can add like a third, fourth, fifth observer, and then all at the same time get these measurements. That would be awesome. Sure.
You know what's funny?
Yeah.
Remember all that time we spent talking about the subsolar point? This is like 2 or 3 years now. People have been bringing that up, and no one has done this subsolar point observation. Why is that?
We're waiting for
somebody
Jeremy.
would have done that with all these people out there buying telescopes and making fucking videos, acting like they're debunking us. How come they haven't done that one?
How many people do you know live in?
Impossible to get exact distances, man. This test all depends on exact distances from point to point during these observations, and not looking at it. It's very important not to look at any model or any map. We need the actual distances, straight line as we can get, and that's going to be very tough. I'm willing to participate in that, If you know, but it's good we talk about it. That's the beginning of everything. Is
You
bringing
do
something
need the
into
exact
existence.
distances. That's true.
How
And you can't
I was
rely on GPS, and you can't rely on globe mathematics to get the distance.
You can, but Brandon, when
No, you can't.
when you're
Not
talking
for
about
this test. Not for this. In order to try to use it as proof of the shape of the
if
Earth,
I
you
wanted
can't
it to
use a
match a flat
reference
Earth-
system that assumes the shape of the Earth in order to prove the shape
Right.
of the
Let me
Earth.
explain
So
why, Brandon. Let me explain
globe
why.
model
If
is
I
not
wanted to match a
scale.
flat Earth model, I'd use the AE map and it'll match the flat Earth perfectly. If I use the distances on the AE map, if I use a globe, it'll match the globe. Okay. You can't use a model. Okay. That's not you.
it
Try to
wouldn't
reinforce the model, but it's not the way shit works.
it wouldn't work on both. But specifically, Brandon, with the subsolar point thing, how many people do you know that live within between the tropics?
Very few. There's only 6 or 7 in this arena that I've come in contact with.
Right.
I could get there. If we had enough people, I could get there.
to get these measurements of the subsolar point, just at face value, there's so few people.
I was
At least
wondering
in
if
this area.
an
Right,
easier
right.
observation would be to film the either the sunrise or the sunset, and you do some in the northern hemisphere and you do some in the southern hemisphere around the solstice times.
We
And
prove flat Earth with that, but they just say it's refracted, bud. They say the sun is not really there. We have proven flat Earth with that very observation. They say the sun's not really there. They're full of shit.
Well, you see where I'm going at. The twilight should be longer. The dawn and the twilight should be longer around the Tropic of Cancer than it is around the Tropic of Capricorn. That would be the claim.
Yeah, that's easily provable. Good point.
And it is.
Did that too.
It absolutely is.
They blame it on refraction.
Everything's wherever they say something's in the sky, that's where it is. But whenever we say something in the sky, it's never where we say it is, but always where they say it is.
All you have is angles. That's the only thing you have. You can't pinpoint any Euclidean position.
Good point,
well,
brother.
what about the zenith though? You know, when it's right over our head.
That's still an angle, though.
That's what we're talking.
Still
That's
an
the
angle,
idea.
Brandon.
Yeah, but angles is all you got.
That's not an angle though. We're just looking straight up. It's a straight line.
It's still an angle.
I mean,
No, it's not an angle. A straight line's not an angle.
No, maybe not an
That's a
angle.
good point, dude. That's a good point. I retract my statement saying it was an angle. You're right, it's just a straight line.
Hold
It's
on,
an
Brian.
angular position. Anything of the celestials is going to be in an angular position in relation to you as the observer.
Unless it's zenith.
Not if it's hold on, Brian.
No.
Not if it's at your zenith though. If it's straight above you, then and you're looking straight at it. I don't know. I can't see how that would be.
Well, that's
angle.
still only an angular position.
You can make a 180-degree angle anywhere on a line.
It would be useful as an angle, good, because then you can perform trigonometry. So if you know that that's a 90-degree angle, and then another observer anywhere, they can form their angle, and then you have a distance between them. There's your trig basics.
Yeah, I did initially agree with Arwen, but Brandon's right. It's one leg of an angle. So they're both kind of right, but Brandon technically is right. It's one arm.
I see what Arwen means though. You have to have the base. You have to have the horizontal in order to put the vertical on top of. But the reason I think that this would work at the zenith, that you could get useful information out of it, that you wouldn't have to rely on any assumptions, is because it wouldn't be governed by perspective at all. You're not comparing it to a horizon or anything. You just know it's right above you.
What kind of useful information can we get out of a zenith angle though?
Just that the sun is right on top of me.
Whatever the case, I'm back on Arwen's side.
I mean, yeah. After that, then what? Like what?
Well, if you get multiple points, you start getting a lot of points, and you know the distances between them. The actual distances, not globe GPS math bullshit distances. Then you could probably start mapping out actual distances.
I was big into that subsolar point thing, but I feel like it's so hard to do. Bev brought things to my attention, so did Witsit. Like, this has a lot of problems with this.
Like
Not
what?
definitive
Like
in
what?
any way.
Like what?
Not
exact measurement.
Yeah, the main problem is that you have to rely on globe measurements, right?
No, there's a serious problem with with getting the actual distance between the thing, like the straight line distance.
Oh yeah,
Right.
yeah, that's
when
true.
You, when you do a
Either
distance,
didn't-
plus
since you
it's
didn't-
going in a curve. Hold on, Chike.
Talking about?
What?
There is no distance. It's not in any position. Just because the angles line up within some kind of presuppositional situation, assumption about how the orientation of things are you're standing on doesn't mean that it's actually in that position.
We
Right?
were
That
talking
would
about
require you to go there
Just the
and
spot.
then
Just
it
the spot
being
itself.
there. It
hold on,
being
we-
there
Arwen.
specifically. And
Arwen.
approach,
Go ahead, Jeremy.
angular size change and all that.
Arwen, we were talking about the subsolar point, the point on the ground, and the distance between as it moves along the path of Earth.
But that's just a derivative
No, we
from
realize it
the
might not be
angular
tangible, are we?
position.
Hold on,
But
bro.
Yeah,
that's
we
all.
realize it might just the spot itself. That light.
Go ahead,
whatever the fuck
Arwen.
it
I
may
didn't
be
hear your
over our
response,
heads,
Arwen.
whenever
Go
it's
ahead.
exactly over our
Angles of shadows are just angular derivatives from celestial angular positions. It doesn't prove anything. Doesn't prove any of it is in any exact position anywhere.
Well, but this is
I don't know. You know that the wouldn't you know that at least the light is coming from directly above you, Arwen? That can't you at least say that much if the sun is exactly at your zenith?
Thus, I know that sunlight is coming from that direction, apparently. In that case, that doesn't prove that where it's coming from. It just proves to you where the light angle is coming from.
And this is another inherent problem with the subsolar point thing that I had going on that Witsit brought to my attention, which was you've got to at this point you've got to start assuming what the sky is doing and making it. Somebody's mic's
Give me a
open.
ding warning before you mute
Somebody's
me.
mic's
Whoever's doing
open.
that. Sorry.
Brandon tried to let I heard him, man. You should thank you.
Anyways,
what's that?
You have to.
Just for the record, there is no problem. Just for the record.
Multiple problems, and we just described them all in detail.
Well, the idea essentially is plotting the movement of the sun as it correlates to its position directly over the Earth in the northern region versus the southern. Like in the north, like taking an AE map type of a concept, where the Tropic of Cancer, when it's on the inner ring, it's going to be tracking along the Earth at a particular rate at its zenith. And then in the southern, if it's an AE type map, it's going to track differently than it does in the north. On a globe, it should track the same.
I'm sorry, guys.
Yeah,
but
so
it's
is it doing a
just
great
your-
circle or what?
It's just your misunderstanding of the model. That's all it is, guys.
What
There's
is?
nothing you can.
Which one?
No, he's just
Everything
trolling.
that they've been talking about, right, Bio?
No, I just don't see the problem. I understand what the concerns are being articulated as. I just don't see the problem because if you have a light source, it doesn't matter what it is. Call it physical, tangible, call it spiritual, whatever you want to say. It is a light source. So if it's seemingly above you and you cast zero shadow, you know that the light source is at zenith in that moment. There is no problem.
Second.
I think the bigger problem is at getting an accurate distance between points.
I think that's challenging, considering a lot of land you can't necessarily go on. You know, it's either private land or government land. So yeah, if you're going to talk about trying to track something across the entire, South America from the east side to the west side, that's going to be difficult. You're going to be in the jungle. It's going to be hard to do.
You're also don't get it twisted. You're also making a model of how the sky works at this point, and then going off of that. So now you're going to judge what Earth is based on the model of the sky that you've built in your head.
No, I was very clear about the very specific thing that we can know is that this light source, whatever it may be, whatever we are standing on, if you're casting zero shadow, it is up directly above you. That you can know for certain.
Okay, and what if we find that it's a faster or the same in the north as it is in the south, right? Well, let's say we say that, you would automatically assume it's a globe based on knowing how the sky works.
But at that point, we have measurements, and we'd have measurements, we'd have calculations. We can form different models based on that information, and whatever follows from that, it would be honest to form conclusions based on it. Sure.
Well,
Except
what-
that
what-
nothing
it
on the
wouldn't-
globe model is to scale, though. That's a bit of a problem, isn't it?
I mean, we can talk about different things like that, but when we
Yeah,
have these
I know.
measurements and when we have these measurements and observations from many data points, and we crunch the numbers, if you will, we can form models that work, and then say, okay, which ones do work, which ones don't, and then move on from there.
Well, the bottom line is that
you think you end up thinking you're on a giant spinning ball.
yeah,
It's
the bottom
possible. I'm
line
not
is
making
this
claims
wouldn't
yet.
The giant spinning ball where the maps are not to scale.
this wouldn't the subsolar point thing wouldn't be a definitive thing for the amount of effort and headache that it would be. I don't even see it that it's worth doing it really.
I think it is. If you were able to decipher that the sun is moving quicker across the land in comparison than it is to the north, I think that would be huge.
I would agree. That would be huge. Sure. That would be the biggest difference between a flat Earth, almost any flat Earth model, and a globe model. That would be the biggest thing and most apparent. So yeah, it would be huge.
I mean, if we're just going off what the sky does, if we're just going to go off what the sky does, we could just pack it up right now, shut the channel down, and I'll go home.
Well, now you're
Man,
exaggerating.
I got an ice cream man driving by, man. I'm
Well,
packing it up for
no,
a second.
Jeremy, come on, man. We can't make any assumptions about what's going on in the sky at all, even selective ones like this object that's making light is directly over us. We can't even do that.
Yeah, I mean, what if we're gonna go off that? Why don't you just go on the equator and see if it's going in a straight line or not? Wouldn't that tell you?
Same thing.
How could this?
No, because then then you've got to factor in
perspective.
perspective. Yeah.
Yeah, as the sun comes up, it'll move to the left in your vision. Draw a horizon.
Yeah, but on a globe, how's that cool? How do you explain that working on a flat Earth? If the sun's going in a
go to my
if
videos.
the
Look
sun's
about
going
five videos back, Jeremy, and you'll see how
If
the
the sun's-
perspective. It's something nobody has
okay,
ever
but if
pointed
it's
out.
moving in a linear path, how can you explain that on the flat Earth?
Okay, go to my video, Jeremy,
Just
and
tell me.
watch the sun. Listen. Okay, watch the sun perspective. Okay, if the sun is doing a concentric circle, it's circling around to the right, and you're looking at it 6,000 miles away. As it gets closer and rises up, it is going to appear further to your left. And as it gets to you, and then starts going away, it's going to start. As it drops, it's going to appear further left. It's going to make a straight line, bro. It's like a real long S, but perspective makes it straighten out both ways.
Perspective. He's talking about the shadow.
There's a request for Brenda to be unmuted, passing the message. but yeah, we can formulate conclusions, just at least at the basic. But this type of observation would be super fantastic because I think that it would be definitive.
Huh. Yeah, that's why it's been done, right?
So what would you do today, right now, BioDual, if somebody, if that measurement was made and indeed it moves faster across the ground in the south, like significantly than it does in the north? What do you then do with all of your things you've been trying to push and argue all this time?
You'll need to be institutionalized. That's what will happen.
No, I gave an honest response yesterday to an opinion, and I got shit on for it, so I'm not going to do that today. Keep it calm. But it would be fantastic. I'd like to participate even if I'm not within the tropics. It would be great because we know distances within the United States. So even despite not being in the tropics, we can still take these measurements and add data to the entire set.
No, see, because that now you're just proving that you don't understand the objections we have and why we want to do a subsolar point when you say stuff like that.
No, it's just adding to it. It would be awesome to have 50 data points within the tropics at zenith. That would be awesome, but we can still add data to it as well.
It's got to be subsolar point data. That's all we're talking about is when the sun is directly over you. That's it.
There's not much difference in the argument. I understand what you're saying, and you want to essentially keep it pure to that discussion, but there's really not. You could do the same thing anywhere on Earth.
You can't.
So also you have to know you also for the subsolar point, you'd have to know the map layout of Earth.
Wait, but Jeremy,
you have to know where the continents are, all kinds of shit.
Yeah, but if you have, all we're doing is determining a straight line between 2 points, and that the sun is over both those points. But you would have to know the path that the sun took between them, the shape of the path. So yeah.
But what Jeremy proposed is very practical, easy to do. You only need one person. You can have more just to verify. Is to check the shadow in the morning, mark the end of it at noon, mark where it is. At the afternoon, mark where it is, or evening, and see if that makes a straight line. This is not possible.
No, we need distances, Strikey.
This is not possible at all.
You're going to use a model
Anywhere.
to prove a model, bro.
I
This
said
is
on the
not
equator.
possible
I
at
said
all.
I said on the equator.
Yes, this is not possible at all. Anywhere if the sun move in a circle.
Yeah, what about the subsolar point on the equator, Brandon? What do you think? If that goes in a straight line.
Yeah, I don't think there's necessarily a problem with the sun appearing to move in a straight line.
Because the amount that the way I see it, the amount that it's arcing around the North Pole is not significant enough to make it look like it's like that level of arc is happening from the perspective point on the ground.
If we're going off the subsolar point and the subsolar point makes a straight path going across the ground, how can you possibly explain that on a flat Earth?
How would you determine that the path is straight, though, Jeremy, and it's not impacted by perspective?
The shadow.
No.
Yes.
We're not playing
As it
shadow
swings out
games.
to the right, higher, it
Shadow.
appears further left.
If it moved in a circle, the shadows will not.
We're not playing
create
shadow
a straight
games.
line. It's not possible. Try it.
We're not playing shadow games.
Well, if you plotted subsolar points, like if you were to plot, let's just say 100 subsolar points, like if you had a private helicopter that you could fly across South America, at the equator, let's say, and you could go whatever number of miles and you could plot, where the shadow is absolutely zero, where the sun is at zenith, you plotted all of those, you could at least start to, then try to put that together and see, of course, what the speed is that it's moving. That would be the actual speed part of it. And then also if that is straight or arcing, but that's going to be more difficult because like Jeremy said, then you'd have to kind of ideally do that in multiple regions so that you could actually, see the layout of the land and how that's actually tracking. But even if you did it in one stretch, you could at least get quite a bit of information from that.
Listen, you guys know I was pushing this hard a while ago, and I mean, I don't know. I think there's better things we could do.
Jeremy, I'm going to post a picture real quick. It's going to be of the horizon in the middle of the piece of paper. It's going to have a sun right at the ground. It's going to have a sun halfway up the piece of paper in the sky, and then a sun at the top. The sun at the top appears further left than the one at the bottom. Just from perspective, bro. That will straighten out. As it goes away, it'll appear further right.
What distance would you consider still being a straight line? In a scale of the entirety of the Earth.
When you're talking about the concentric circles that the subsolar point would make. Shit, I don't know. We'd have to do some math on that to see where,
Because if you're talking about 10 kilometers, I mean, that wouldn't tell you anything about being straight or a curve.
Right. And would it even like the entire breadth of South America? Is that even enough? I mean, if the southern oceans are very wide, that's actually a pretty small section of the whole thing.
That's what I'm saying. Yeah.
It's kind of close.
Oh no, bro. Like if you take the entirety and the scale, think about it, like 20, 100 miles is not enough to declare it to be straight.
Oh no, you need at least 400 or 500 miles. That's kind of close.
The problem is that we're too small, right, to do these kind of things, because at that point, there's so many variables that you gotta take into account that everything starts going really bad.
Just if you have one person that is at a known zenith location, you could do sunrise to sunset. That's gonna cover a shit. That's gonna cover a shit ton of mileage, obviously.
That's not how you would do it.
No, you'll tell me that the sun's not really there. What you'll do, Bogul, is you'll tell me. Oh, sorry. Go ahead.
Yeah. Well, I was gonna say you need to actually walk walk the distance, and so that you cannot for this test you cannot take Google Maps or shit like that to give you indications. You gotta do
Yeah,
it.
I didn't
with
mention
the
that at all.
compass. You gotta do it.
That's what I was
Listen,
saying.
even if you walk it, hold on. Even if you walk it, you're going up and down hills, or you're going in a straight line. Like that's not the easiest thing to do. Just go in a straight line. You'd have to like snap a line or something. Like is the amount of work that this would take is ridiculous.
That's why I was saying a helicopter, because if you had a helicopter, you could actually, land it wherever you want, essentially. I mean, not anywhere you want, but you could find places to land it where you could, go 50 miles, land somewhere. Whereas an airplane, you have to find an airport and everything. But a helicopter, you might be able to plot.
That's true.
Yeah, if you had a good drone in a couple of years, you could do it.
Now drones, they only go about 5 miles if you have a really good one. Then
Yeah, and they use GPS. Can't trust it.
no. There's ones where you have your antenna with the radio, and you put the Google zone and just launch that thing, and you can drive it up to 5 miles, I think.
Listen, does anyone hold on? Does anyone have anything that will operate something tangible, no optical shit, something that will operate in only a straight line or move only in a straight line or something like that?
Jeremy, we try to give them microwave distances. They claim refraction. Everything we try to prove, they fucking claim refraction, dude. And they stick with their model. They're full
That's
of
why
shit,
it can't be optical. It can't be anything optical.
Right? It's really difficult, right, Jeremy? Because if you send a drone, let's say you can program it so that it doesn't deviate from the initial point. It doesn't deviate at all, but the problem is that the wind may push it a little bit. So that's a problem also.
Yeah, but if you've got a bunch of pictures of the ground from a certain height, it'd take forever, but it's feasibly, it could be done.
Rob Keane reminds us that level is horizontal. Thank you, Rob. Indeed, sir. Appreciate it.
So the point is, I went over this with drone people, and they say you can't make it go in a straight line.
It is tough. I lost mine first time I used it. But check this out. Rob is correct, y'all. Rob is correct. We're trying to come up with a test to prove to them, because everything we show them, they have an excuse for it. And then they say they got measurements, which we know is a fucking lie. And they don't even understand that they're, well, I won't say a lie because they're ignorant. But everything we try to give them, they have an excuse for it. They say the microwaves, it's bending around the Earth. We use sonar like in submarines because there's what is known as an acoustic shadow. And so the ground gets in the way. But for whales who can call for over 4,000 miles from Africa to freaking Australia, they say that now the sonar is bending around the Earth. They say microwaves are bending around the Earth. They say the sunlight's bending around the Earth. Everything we give them,
Lasers.
They got a fucking excuse.
Waves will
Of course,
diffract.
they've been doing it for 500 years. Sorry, Brenda.
Well, waves will diffract around corners. Yeah.
Oh yeah.
So sound waves will bounce from different density layers in the ocean and travel a long distance.
So then I take my instrument and I go along the coastline and get tangible measurements and to prove it's flat. They tell me that I am shooting my way around a globe. I just don't know it. So the horizontal line that I'm measuring, actual measurement, they say I'm shooting my way around a globe. So just to get this straight, in real life, all the elevation shots all we get is elevation changes. We do not get Earth curve. You can add in Earth curve, but it's not in the physical measurements, people.
Yeah, if you go out with an auto level, they'll say you're changing your plumb you're horizontal every time.
Right.
Well, yeah, of course.
That's the
what he's
plumb
doing.
lines aren't parallel nonsense.
Yeah, he's establishing a new horizontal at every station. Yeah.
No, he's not.
Well, that's what he says he does. That's what I
Same
understand.
horizontal. It's on the same
That's the next
plane.
day I do.
I'm just saying that is what I understood him to mean.
Oh, at each location? Is that what you meant?
Yeah, that he's shooting from a new horizontal from each location, not from beginning to the end point.
Highly unlikely. Highly unlikely.
Were you back shooting?
Nah, man, I didn't do no back shooting, man. I should have went further, but man, they're just gonna say they're gonna add their curvature corrections and say that I'm going around the globe, especially if I back shoot.
The best thing I've ever seen.
They're gonna say every point I had was horizontal at that one section, at that one tiny point. They won't say the distance of that section, but they'll call that point horizontal.
The best thing I've ever. All right, go ahead.
That's okay, but I just want to establish, Brian, did you take a final measurement from the beginning of your measurements all the way to the end, or did you take separate measurements at each point?
No, I did a beginning and an end. I marked a spot on the pier, and I went back to check it in case the tide, to see how much the tide had affected it. And granted, I didn't go as far as I wanted to, but I'm sitting there going, and I'm getting no change at all. And I'm like, I'm like, how can it just start curving all of a sudden? I'm shooting, I'm getting level, going about 100, not quite 100 yards a pop, stretching it a little bit, I do admit, but it's not curving. I'm like, how can it just all of a sudden start curving up further up the beach than it is right where I'm measuring here?
Well, Brian, if you're getting level, those are independent measurements, right?
Yep.
Yeah, you're establishing a new horizontal each time.
I'd say it's slightly possible, but very highly unlikely, Brendan, in my opinion.
That's exactly what it sounds like, though. Is that you're making these small shots, but you're not you're not adding to a distance of a shot. You're doing the same distance at different locations.
Here's the problem: the margin of error is so small that if I did like Rakia did, and he used lasers, he went a little bit further than me, and he did it on the bayou and shit, and in shallow water with jet skis. Okay, and they did bat shots and everything with lasers. They set up multiple pegs. He proved no curve, but they're going to say that each setup, each peg, the margin of error is too small. They got an excuse for everything, BioDuel.
Yeah, are
the error bars too small? Right, but a legitimate question, Brian. Are the error bars too small for those distances?
Possibly, man. Possibly.
Right.
But when
So
you get
isn't
out
that
there,
a legitimate Isn't that a legitimate response, though? If the error bars are falling within what we'd expect, isn't that a legitimate issue?
Listen, you make it unfucking falsifiable, though, bro. When you get out there and you're doing it, you realize that, hey, how can I start curving all of a sudden when I just went a mile and I got nothing? How all of a sudden can the next mile fucking curve, dude?
Brian, let me jump in real quick.
It's possible mathematically, guys, but it's y'all make it unfalsifiable, bro. Y'all got an excuse for everything.
Yeah, we know. We heard it. The best thing I've ever seen to do optically was something that Bev proposed. I forgot the name of it. It's where you look through your auto level, right? And then you make two marks. You make two posts, one at 50 feet, one at 75 feet, or whatever they use, meters. I don't know. But then you have two posts to work with, so you can get closer to, or I don't know. You use more than one post, and you don't change your plumb line. You just go off of the marks that you already have, something like that. I can't remember the exact procedure, but
it's very confusing, Jeremy.
yeah. Well, I mean, you'd make an optical. You'd sight two things in the distance, two or three things, and then you'd move forward, sight on the next two or things, and make another mark in front of that, and then you could keep going like that without changing your plumb, like you guys say we're doing.
Doug, they'll still say the margin of error is too small, though, Jeremy. But that is a great idea. But listen, y'all, the curvature is in y'all's minds. Okay, it's not out there in reality. It's the light bends. Okay, light bends, and y'all's minds bending. The curvature is in y'all's minds, people. Promise.
But Jeremy, you would be establishing a new horizontal each time you move the station.
No. If you're not using the plumb line, the plumb thing at all. You're just strictly going off optically what you see on the marks on the posts.
Yeah, but the plumb is.
You're not worried about level. You're not worried about level at that point. You're just going off of the post and the crosshairs.
So the mark. What is the? So you have like a surveyor stick, right? It's in the ground, and you're sighting it, and then you mark the.
You put a post 5
meters.
feet. You go out 25 meters. You put a post at 5 feet. You go out 50 meters. You put another post at 5 feet.
And then
you go out 75 meters. You put another post at 5 feet. Now you move the auto level.
Jeremy, at this point, it's
Now you move the auto level towards the. You guys don't want to hear it then? Okay.
Those would all be independent zeniths.
Yeah, but you shoot multiple story poles out from one location, though, Brenda.
Yeah, I mean, you didn't even let me finish. You obviously don't want to hear it.
Go ahead.
You have it. You have your auto level in one spot. You don't move it. You make a post. You go out with the stick. You put a post in at 5 feet. You go out 50 feet. Put another post down at 5 feet. Your auto level didn't move. You put another post out at 75 feet. You now have 3 posts at 5 feet high. You can now move the auto level. And when you set it up at the 25-foot post and you look out at the 50 and 75-foot one, you just line it up off of that. You don't worry about the plumb.
Yeah, that isn't going to show curvature.
That's what Rakia did, y'all. That's how Rakia did it.
Of course it's not going to show curvature because Earth's not curving.
No, it's not show curvature because it's not designed to show curvature. It's designed.
It's designed to make a straight line in free space. That's what an auto level does.
Are you doing this wrong so you don't find the curve? I don't get it.
We're going to make a straight line.
Yes,
we're going to make it.
Does that
an auto level make a straight line? In Brenda, does an auto level make a straight line?
What you would have would be 3 point. Just a minute.
Does an auto level make a straight line? Ask your question.
What you would have is 3 points, 3 survey points, all 5 feet above the ground there, right?
You would have had those 3 posts are now horizontal.
They're all 5 feet above the ground, right?
Horizontal.
The ground don't matter, the ground don't matter.
I don't know how many. I don't know how far they are above the ground. That is now made a horizontal line.
They're all. How do you know it's horizontal?
Do you know what an auto level does? Do you know what an auto level does? Brenda, what's an auto level do?
Do you know that those lines are horizontal? If the
Brenda,
Earth is curved,
Brenda.
if the Earth is curved, the further one would be down from.
We're not worried about how high it is or low it is off the ground right now.
That's the problem.
No, you're not understand. Listen, do you know what an auto level does, Brenda? Tell me what an auto level does.
It sights along. It establishes a local horizontal.
Okay.
Right.
So we're gonna make these 3 posts. Hold on, Brian. We're gonna make these 3 posts be horizontal, right? Because we got them all. Straight up. Oh, my bad. You know what? I described it wrong at the beginning because I said 5 feet.
God.
My bad. We're gonna make a horizontal line. You're not worried about how. It doesn't matter how high it is. We're gonna put the posts right on the crosshairs. Okay, my bad. I'm sorry. My apologies.
Yeah, but let me pick you up real quick. The thing is, you just need a reference at the beginning. When I did my test, I made a mark on the pier, and that's so right where I had my auto level. I put a mark. It was about 4 foot.
Brian,
Yeah,
do you understand now, Brenda? What we're gonna do? We're gonna make all those posts be right on the horizontal.
You have an auto level station set up. You've established zenith, and then you set it level, and then you have 3 posts marked out at separate distances away from it, right?
Yep.
And then
all on that horizontal line, right?
Right, and then you sight along the horizontal, right?
So now we got this horizontal line with 3 posts.
Right.
All the tops of these posts form a horizontal line, right?
Right. So if the Earth is curved, I would expect the distant one to be higher higher than the close one.
You're not going to know after 75 feet, though, so you're going to have to move the auto level.
75 feet is nothing. I mean, I don't.
Yeah, I mean that's the max distance. I mean you wouldn't want to go much farther than that with an auto level. But anyways,
you'd use
you can now move your auto level forward to the 25-foot mark and just use the top of the other posts.
No, then you're establishing a new horizontal.
No, you're not worried about. You're not worried about plumb. You're just going optically off the top of the 2 posts.
Worried about plumb.
Yeah, you're going to do it You're going to still make a horizontal line, but you're going to do it with all the posts you just made.
Then how do you know that second station isn't is horizontal to the first one?
Because we made him be a horizontal line at the beginning. Remember the step 1?
But now it's pointing directly at the third one, right? There could be an angle there. Instead of
we're going to have 2 posts. We're going to have 2 posts in front of us. There's going to be 2 posts. We could even do 3 or 4 posts. Hold on, Brian. Jeez, coming like a bull in a china shop. We're going to have 2. You could do 2, 3, 4 posts in front of you, and then you don't worry about plumb. You just sight it off the posts. You get a little bit closer. Why is it a problem?
Because if the Earth is curved, this isn't going to show that.
Why? We're going to keep our horizontal going all the way down.
But you don't know that you're keeping horizontal. You're pointing at the third post from the second station. You don't know that that angle isn't like 181 degrees or 182 degrees. You don't know.
No. We're gonna stay behind the first or second post or something. We're gonna stay behind the first post. We're gonna get 20 meters, 20 feet, whatever, 20 yards closer.
No, I know, but you.
And then we're gonna use the.
Jeremy, give me 1 second.
Go ahead,
Brenda.
Brian. Go ahead.
Brenda, think of overlapping string lines, Brenda. Brenda, quit talking. Think of overlapping string lines, Brenda. So what he's talking about is his next setup. He's only going halfway past his post. So think of his first setup as a string line between all three posts, and then think of him only going halfway to the middle post and setting up another string line, just extending it out a little bit further. So think of overlapping string lines. Okay, on a globe, they would not be parallel.
So on a curvature, you don't know that at the second post, when you're sighting the third post, that angle from A, B, C isn't greater than 180 degrees.
You're going to be at Brenda. You're going to be at A. You're going to now move you're going to move your auto level forward a little bit. You're going to move your auto level forward a little bit. Brenda, let me explain. Can I explain? Relax. You're going to move your auto level forward a little bit, and then you're going to be able to see you're going to have two targets. Right, you're gonna line them up on a horizontal, so they're horizontal, and you're gonna be able to project another post out farther. And you can keep leapfrogging like that. You're not changing your horizontal. You're just keeping on the same horizontal.
So I have 3 points, A, B, and C. I set up zenith and horizontal at A. I move to B, right, and then I sight C. And
no, you're not moving to B. Stop. You're not moving to B.
I'm moving to.
You move to A.
No.
Now you have B and C. No, you set 3 up. 25, 50, and 75 meters. A, B, C.
Yes, that's what I said.
Once you get them all set up, you move to A, and now you have B and C in your sights.
But what about the first one?
We're at the first one now. We're going to leapfrog this the whole way. How do you not understand this?
Yeah, it's donkey talk. Donkey talk.
I don't know why you're leaving out the first one.
Because you're a donkey. Everybody understands but you, Brenda.
We use the first one. We're now at it. We're at the first one. We're going to look at B and C now.
First one.
When we put D in, we're going to move to B.
No, let's call A, B, C, and D. We start with A, right? And then we set up. We cite A, B, and C, right? And then we move to A. Right, and then we cite. Is that right? Do I have that right?
Brenda, you're going to set up three points in front of you. Brenda, you're going to set up 3 points in front of you. Brenda, you're going to set up 3 points in front of you in a horizontal line. You know they're horizontal. Then you're going to go to the first one, and you're going to be able to see that's next to. What's so hard about this? This is
okay. I thought you were going to straight line. Just a minute, I'm confused. So I thought you were setting up a straight line. You mean you're?
We are setting up a straight line.
So I meant from the first position is an arc, right? The first position makes an arc, right?
No, why? The horizontal makes a straight. No, we're gonna put all the poles. Relax.
We're gonna need to draw.
We're gonna put all the poles. Listen, we're gonna have our auto level out in the field or whatever next to some water. We're gonna put 3 poles all at the horizontal point of the auto level, right? So now we got a horizontal point, a line between these 3 poles. Do you understand?
All in a straight line, never touching the auto level, right?
Yeah, they're not going to touch. The poles aren't going to touch the auto level.
That's not what I said. Not moving the sights of the auto level.
Yeah, not moving the sights at all. We're not moving the auto level. We're going to set up 3. Hi, Adam. We're not moving the sights. We're going to set up.
Right. And then we set them up. They're all lined from the first point. And then we move to A, right?
Come here, bud.
Then we move to A.
Come here. Yes.
And then is A, do we establish a zenith at A?
Nope.
You set up your auto level at the same exact height, Brenda.
Why wouldn't I set up a zenith at A?
Because now you're only concerned about keeping that horizontal.
Well,
So you're only going to go off of,
Just
you're only going to go off of B and C.
how do I know if the site, if the eyepiece is pointing horizontal?
It's an auto level. It's the most accurate tool there is. Do you understand now? You're picturing overlapping string lines, right, Brendan? George says at the end of them string lines, you'll work your way up off the ground. It'll get higher and higher.
But if I don't set up a zenith, how do I know that I'm sighting horizontal?
You have a reference at the beginning of the test and a reference at the very end of the test.
But
the further you go, the more clarity you'll get.
It could be wrong.
Well, tell that to George because we went through it and he understood. I think Rubbish. I'm pretty sure everybody understands, but you just picture an overlapping string line, Brendan.
Well, maybe
picture an overlapping string line.
I don't know how at the A station you know that your auto level is sighting perpendicular to zenith.
Because you're using an auto level. Okay,
You're not worried about. No, stop.
Auto level
You're not.
doesn't automatically. You have to establish your zenith.
Brenda, stop. The auto level can still make a straight line.
That's a theodolite, Brenda. Sorry, Jeremy, but she's talking about a theodolite.
Let me just get this over with. I got things to
You
do.
guys, listen. You guys are getting trolled. You don't even know it.
I'm not trolling. I genuinely.
Yeah, you are.
I do.
No, you're not. Well, then you're sea lioning. You're sea lioning. Stop sea lioning.
I'll stop. Maybe somebody can draw it out for me. Maybe then I will understand.
No, you understand perfectly what's going on. You're just playing stupid.
Go to my third video, Brenda. Brenda, go to my channel. It's about 3 years ago. I put out a video with the same idea. It's my oldest video, like my second or third video ever on flat earth tests. Okay, I make it clear as a bell, and I actually set it up in the yard.
Brian, Travis is right. She's fucking sea lining and trolling.
I don't get it. I don't understand. How can you not establish a zenith? What if it's not accurate? What if you guys are just getting strung along, man?
After years, are you telling me you don't understand what they're saying, Brenda? After these years that we've been doing it?
Because he's saying he doesn't need to establish a perpendicular at the second station.
Don't take the bait. Just let's move on.
Because listen, you're going to hold on, just real quick. You're gonna the auto. I can't help it. Listen, the auto.
Somebody needs to make one of those sounds like when the fish hits the line and it just goes ring. Take it off.
All right, go ahead. Whatever. Just go.
Anybody got anything that they want to talk about?
This was the best optical.
I'm willing to drop it.
This was the best way to optically make a horizontal. This was the best way to make optically make a horizontal line that I've ever seen. Just saying.
There's no guarantee it's horizontal.
Yes, it is, Brenda. The scope of a auto level is automatically. I know, right? But it's automatically horizontal. Okay. What you see through that auto level when set up properly is.
Sorry, Brandon. I just wanted to make one closing statement.
Oh.
Go ahead.
What else is going on, guys? Who's got something on their mind they want to talk about? Floor's open.
Yo, what's up? Holla. Off work, man.
I'd like to ask a baller.
I drive back.
I'd like to ask a
What's up,
baller
Gypsy?
where should the sun be in America for it to be on the horizon, like 5 degrees in Australia?
Who
Where
fucking
you feel
knows?
sharp pain.
Who knows, Brian? Australia's probably not even where they show us.
Gypsy, do you have a hot mic, or are you saying something?
No, man, I'm trying to talk. I'm just driving right now. I just picked up a joint. I'm a bowler. Someone asked me something. You got me for an hour. I got an hour drive back home.
Okay, if the sun is on the horizon 5 degrees in Australia, on the east coast of Australia, where is it located over North America or over the Pacific Ocean?
Green.
Green. Yeah, I like Travis's fishing reel.
Hold
That's
on.
fucking hilarious.
Hold on a sec. I just heard some funky sound from my brakes. What the fuck? Hold on. Sorry. Trying to.
You know this is a live show, right, Gypsy?
Brandon, get the donkey sound effects and the fishing line, the fishing reel sound effects, dude. That would be funny as shit, dude. The donkey.
I'll have
and
to
the fishing
find that.
line.
I will.
Okay, I'm ready. I'm ready for a show. I'm driving too, so the sun thing, I don't know. I gotta look at like fucking maps and shit to measure that. Ask me something else.
I'll give you another one. Okay, if you're driving, take a cumulus cloud up on the distance. Okay, how far do you think you have to drive before you hit the clouds off in the distance that are just like right above the tree line, that are disappearing below the tree line?
That's a good question.
The
I'm gonna
answer is
say
about 11 or 12 miles.
right up the what?
When I did it, it was about between 11 and 12 miles from where I was at. I looked at my odometer and I picked a cloud that was a big ass cumulus cloud that was like halfway under the trees, and in the distance, and about 11, 12 miles I was underneath it. But I don't know if that varies. I mean, it would have to vary sometimes, but for that to be Earth curved, then that would be a mile of curvature. If that cumulus cloud was a mile in the air, that would be 1 mile of curvature in 11 miles or 12 miles distance. That should prove it's
Yeah, that's not how curvature works. It's not.
Curvature don't work. That's why we're here, Brenda.
Well, I mean, curvature does work.
What is the name of your other channel, Brian? I can't remember.
It's called Flat Earth Test. Capital F, space between flat, space between Earth. It's Flat Earth Tests. Capital F, capital E, capital T.
I mean, all I ask from a flat earther is like just expand your fucking vision of what you're looking at. You know, you want to make all these claims about 10-mile distance observations or 100 miles or holy shit, look at this, we're on top of a mountain seeing 500 miles.
That's where we came from.
What is 500 miles to 198 million square miles? It's peanuts. It's dust in the wind.
Listen, that's where we came from. We came from a place where we were taught what to think about the Earth. Our minds were open enough to evaluate and critique that information. So we are open-minded to consider. So what are you talking about?
Long distance observations are not really long distance. I mean, to us, yeah, sure, they're long distance, but if you take a planetary size, like it's the fraction of a speck of a fart. You know, like it's nothing. It's 500 miles. It's at 190 million square miles. You know.
Okay, all right. So fair enough. So have you personally done anything to validate what you believe the Earth to be that you have tested? Not that you just simply take a science book or a college course or even a PhD graduate course. You're not taking anybody's word. What have you done that has verified what you think is true about the nature of the world?
Real quick, Brandon, I put a video in general so you can link.
Yeah, thank you.
So about for 4 years, not this year because I sold my house. I owned a house on the lake, and it's one of the largest freshwater lakes in North America. I had a viewing span of, what was it, 450K north. But it got shallower, right?
Tell us how flat it looked.
Picture like an oval, very thin oval type thing, and I'm the bottom left of the oval that I can look to the right and then up. So I had differences in distance and whatnot. I also owned a telescope. And these lakes are freshwater. There's like no tides, hardly ever tides. My screensaver is like a mirror of what the lake used to be.
Why ain't there tides?
So, off in the distance,
It's a lake, Brian.
You know, you get the days when, because you were talking about clouds. You get the days where you get clouds where it's like the puffy tops and the flat bottoms. You know what clouds I'm talking about?
Yeah, those are the
cumulus clouds. Is that what they're called?
Oh damn! Like, you got a name. Yeah, with the really flat bottoms and the anyway. So off in the distance, whether it be 450K or 40 to 70 to 80, 90K, whatever, right? Variance. With the naked eye, and my property is a good 20 feet above the lake water level. 30 feet. My deck, I was on my deck, so like 40 feet. Looking out with my naked eye, you can see the bottom of these clouds, and then you can't see the bottom anymore, but you can see like the puffy tops because they're scattered, right? Way off in the distance. So I pulled out my telescope and I looked at it, and I still couldn't bring back the bottom of these flat bottom puffy top clouds. wind. You're not going to have a cloud, one random cloud. It wasn't one. It was like 100. There's a lot of clouds in the sky, right? You're not going to have one cloud just randomly drop lower than the rest. I mean, not out here anyway. We do get tornadoes, but that's pretty rare. So there's that, right? That I've done myself. Around my neck right now is a precious metal that could only come from a supernova. There's another thing.
What? Whoa, hold on. We gotta stop there,
wait,
Gypsy.
Wait, I've got
All right.
something around my neck that could only come from the mouth of a unicorn. I mean, come on, man. Who told you that?
What do you mean? Come on. Well, can please help me understand how and where does gold, silver, and platinum come from?
The Earth.
Okay, where does it come? What creates it?
The Earth.
And you can't say God. How does Earth create it?
I don't know, bro.
Well, do you know they figured out how?
Dude,
Yeah,
you're talking philosophy, bro.
Yeah,
You're
we're all
talking philosophy.
stardust. We're all stardust.
This is a philosophy, but technically, yeah, we are stardust. But this is a philosophy.
Okay, why don't we?
Bro,
Why
what
don't
is
you
a
just
fucking
listen?
star?
No. Let's listen. Hold on. No. Let's go. Let's stick with the cloud. Let's stick with the cloud and the vanishing point. If anybody wants to address that point with him.
What point?
I said it with the naked eye, and then I had a telescope, and then I fucking viewed it. And
Okay, all right.
The weather was fine, so yeah, that's
right.
That's
So you've got. Okay, so you've got a direct line of sight to the horizon, and at the horizon you've got a large cloud whose bottom that you cannot see, correct?
wrong. Hundreds, if not 1,000 clouds, not just one, but pretty much, yeah. Go on.
Okay, so are you under the impression that at that distance where the apparent sky and water meet, that you should have absolute clarity of sight?
Yeah, when I see the same thing when I'm lake level or about 40 feet above the lake. Same spot. I'm about
that
40
works
feet
fine
up.
on a flat Earth model.
I'm about
Okay.
40 feet up and 40 feet back.
Okay, so the 40 feet back I don't think really matters anymore that much. So, but you're saying that you're 40 feet off the ground, off the water, right?
Yeah. And
Okay.
on the water too. So I checked it from both, and it hardly changed. But no matter what, it just wouldn't come.
No, I get that. Again, though, I think our position would be that your eye's ability to resolve something at that acute of an angle is very, very limited. Your eye is not going to be able to resolve the information once it gets to that degree. Now, the cloud is bigger than the point of convergence, and by point of convergence, I mean that place where the sky and the earth apparently come together. The cloud is higher than that. So let's just, by analogy, put a boat out on the water. You can see the sail of the boat. And if it's a large sailboat, you might even see the deck, but then you can't really see the hull. It's kind of, at that degree, your eye is losing the ability to resolve that information. That's
not
all
to mention the cloud dropped a mile.
Why can you see
Wait,
this?
not to mention, hold on, Brendan, not to mention the cloud dropped a mile. The boat hasn't dropped barely any at all.
But why can you see the cloud?
Hold on, I can handle this, guys. Hold on. Okay, so you're talking about like it being too far away to see, like it just angle of whatever, right? Then how do you explain? Actually, no, I can't even bring that up.
Okay, so let me. Okay, hold on. Okay, all right. So
mountaintop.
Okay, just hold on for a second. So I've got enough experience taking photographs on the Channel Islands. Okay, Anacapa Island is 20 miles away. Now I can see the lighthouse with my naked eye at times. Okay, that lighthouse sits 272 feet high. It's a 50-foot lighthouse, so it sits at 220. Okay, it's on the ground at 220, so that's 220 feet of land that I can see directly in front of me. But I can't see the coastline of the island, but it's right there in front of me. But I can't resolve it because of the information that is crammed into that tiny angle. So, Brenda, if you're going to ask the question, how come you can see the cloud? Because it's higher than that lower angle. I can see the lighthouse because it's higher. There's more, or there's less information being crowded at that angle, and so I can resolve the lighthouse.
Even though they're wrong, that's probably the best answer I've ever gotten back for that. Every other answer is you're lying. Like,
now,
dude,
let me
come
ask
on,
him a question real quick. Hey, I like your honesty. Let me ask you a question. In your world, if you're on the equator in July and you're looking up at the night sky at exactly midnight, you're looking exactly away from the sun, correct?
Wait, equator, midnight, and where?
Well, let's just say you're exactly opposite of the sun at the equator whenever. You're looking away from the sun, right? You're looking off into space, right directly overhead. Now, 6 months later, in your world, you're looking exactly opposite from that point in space, right? You're looking exactly opposite. You've rotated halfway around the sun, and it's midnight again. You're looking exactly opposite of where you were 6 months previous, correct?
No.
What do you mean?
Okay, you're gonna have to. You're gonna.
If you can't mentally
can.
get past a dome, then it's gonna be hard for you to fathom the sheer size of everything else around us.
I'm talking angles. Let's do it on the equinox. Okay, on the equinox when the sun goes directly over the equator.
Hold on, Brian. Hold on. So, what's your name again? Gypsies or Gypsy?
Oh wait, you said equator.
Hold on.
I mean, no, he's still.
Okay, Brian is. Put yourself in the middle of a neighborhood in a cul-de-sac. Okay, Brian's talking about facing one direction, and you see the even number houses, and then you turn around 180 and you see the odd number houses. He's saying that at one point in the year, you're on the equator and you're facing the odd houses in space. 6 months later, you've now turned 180 degrees where you should see even number houses, but you don't. You see the odd number houses still.
This shit's so easy, man. 23 hours and 56 minutes, 4 minutes off each day. Over 6 months, it's about 7,200 minutes. Divided by 60 gives you about 12 hours. Every 6 months, you're about 12 hours off. Sounds like
that reinforces my argument, bro. That reinforces my argument. Because if it were 24 hours, you'd be looking the same damn direction. It's 23 and a half. So that puts you halfway around that makes a half rotation.
Yeah, I agree. If it was 24 hours exactly.
It's called a sidereal day. It's called a sidereal day. And if you take a sidereal day, 6 months later, you're looking opposite the sun. You're looking in a different spot of the universe, and you can see Orion at least 9 months out of the year, and that's an equatorial constellation. That's still the globe.
Brian, I went over this one day, and that 4 minutes gets made up from the rotation. If you just think about it in your head, or you might need to see a diagram or something. But
yeah, the sidereal day,
the rotation.
Right.
The rotation around they claim the rotation around the sun makes up for it, and it would in their model. It would.
The rotation of the Earth makes up for it, not the rotation around the sun.
Okay.
No, it's the rotation around the sun.
Listen, Jeremy.
No, it's the rotation around the sun.
Oh, hold on, you guys are kind of both right.
In the middle of your orbit.
Listen to me for a second so I can clarify this, please. It's the shortfall because the Earth is orbiting the sun. When it rotates, it's at a slightly different angle. It's like 4 minutes off, making a complete revolution when solar noon comes up again.
Yeah, it's the orbit around the sun.
Day, but listen,
it's both
before
of them.
y'all fall too deep into their bullshit, let's take a sun, let's simulate a sun and put it in the middle of a room. I don't care how many times. Then now let's take a globe. Okay, the soccer ball is the sun. It's in the middle of the room. The globe is on one side of the room. I don't care how you spin that fucking soccer ball. if you rotate it halfway around the sun, nighttime is going to be looking in the opposite direction. It doesn't matter what way you spin that motherfucker. Nighttime away from the sun is going to be opposite. Don't let them fool you.
It won't, because of the 4-minute delay each day. So halfway across the year is about 180 days.
Okay,
and
so
if you
I'm
compute that
looking
of
at
4
the
minutes
sun,
per
hold
day,
on.
it's about, hold on, Brian, hold on. It's going to give you about 7,200 minutes that this delay
It
occurs
doesn't
in 6
matter,
months.
bro.
That's about
That's a globe killer then.
Brian. That's about 12 hours, meaning half a day. So the difference between one end of this revolution and the other end, you're halfway skewed, meaning your noon is still facing the sun. What is the problem?
Okay, let me try this. Draw a 6 on one wall.
Wait. I'm sorry. The last thing you just said was your noon is facing the sun?
Yes, because you're 12
Of course
hours
it is.
off in space. In the position of space, you're 12 hours off. So on the other end of this revolution, you're looking in the other absolute direction, which means you're
I'm
still
telling you
looking
guys
at
right
the
now,
sun
in their
at noon.
model,
Hold on.
in this model.
Hold on, Jeremy. I'm sorry. I'm just trying to understand. Okay, I'm honestly trying to grasp what you're saying. When you say your noon is still looking at the sun, that's redundant. We're not talking about looking at noon. We're talking about looking at midnight 6 months later.
Okay, what pick a time. I can give two shits. If your absolute direction is one way on one side of this revolution, when you're 12 hours off, you're going to be looking in another absolute direction. But because you're on the other side of this revolution, you're still looking at the sun.
Let me tell you that
We're not looking at the sun. We're not looking at the sun.
4 minutes is half a rotation in 6 months, guys. That 4 minutes, I repeat, that 4 minutes a day equals 180 degrees in 6 months. That puts you exactly fucking opposite of where you were 6 months previous.
Right.
Do the math.
Brian,
I'll bet anybody
Brian.
$1,000.
Hold on, Bio.
Go ahead. Yeah.
Brian, I'm telling you right now, the orbit around the sun makes up for that 4 minutes every day, and it keeps you facing. It keeps noon. It keeps noon staying.
Yeah.
Okay,
it keeps noon staying.
Hold on.
So in 15 days, that's 1 degree. Right?
Orbit around the sun.
I know, just in their model. I'm saying in their model.
Jeremy, would
It
you like
doesn't
to
break
bet
their. It doesn't
$1,000?
break their model because that's what their model dictates. This.
Jeremy, would you like to bet 1,000? Or let's just keep it friendly. Let's keep it $100. Hold on.
Y'all keep it
I'm just
going.
saying-
Y'all keep it alive.
Jeremy,
It's dead.
would you bet me $100 that the sun is 180 degrees opposite in 6 months?
Hold on, Rocky. Leaky was saying that this was a globe killer, but it's right in their model as stated, as it's supposed to work in their
DNR. It's
model.
called DNR.
There you go.
DNR. Do not resuscitate. The
Hold
globe
on,
model
man.
is dead. DNR.
I want to
that
make a
son.
point.
Yeah,
Jeremy,
make your
Exactly.
point.
Do not
Reapply
resuscitate.
the globe model.
Let's not
Bring it back.
resuscitate.
Jumping on me, man. I
Let's
just
not
wanna make one
resuscitate,
point, man.
Brian.
I'm right in the middle of trying to get my argument out here. Okay, so Jeremy, you willing to bet $100 that in 6 months, at 4 minutes a day, that's every 15 days, that's 1 degree. So would you be willing to bet me $100 that in 6 months, you're 180 degrees opposite? You willing to bet $100?
No,
Of
Leaky,
course,
listen. And
of course you're on the other side. But because this 4 minute delay adds up to about 12 hours, 12 hours half our day, 50%. So
It adds up to 180 degrees, Bowdoin.
Brian,
Bowdoin. Hold on, man. It adds up to 180 degrees in 6 months.
You're not listening. You're not listening to him.
I promise you, Brian. I went over.
For
Then
that.
bet me, bud. Then bet me.
Brian, I promise you, I went over this with him one
Bet
day.
him.
It says
Take his
in the
money,
model,
Jeremy.
the four. I
Yeah,
don't
take
want it.
your
I
money.
don't need $100. Like.
It ain't gonna kill you.
One thing he's wrong, but even his side. But Brian, you. I'll bet you $100.
I'm telling you, I was going over this in my mind one day in here, and I figured it out.
I've got a
that
globe in the middle of my room right now, bro. I got a globe in the middle of my room. I mean, I got a soccer ball in the middle of my room, and I got a globe on one wall. And now listen, if I were to spin it the whole 360 degrees, then it would be facing the sun 6 months later. Okay, but since it's off, listen, since it's off by 4 minutes a day, every 15 days, that's 1 degree. So in 180 days, it's 180 degrees opposite.
No, Brian, you need to listen to yourself right now. If you're talking about 180 degrees and 180 days, it's 1 degree per day.
I'm sorry, I meant 6 months. It's one. No, it ain't. It's 1 degree. It ain't. You think 4 minutes equals 1 degree?
Hold
It's
on.
15 days for 1 degree, bud.
Hold on. Just think about what you're saying. In
I mean, hold on.
Hold on. Yes, please reevaluate what you're saying. In 180 days, it's 180 degrees off. How many degrees per day?
Okay, yeah, it's not no degrees. It's only 4 minutes a day. So you need 15 days for 1 degree, bud. I mean, you need 15 days for 15 degrees. I'm sorry, I meant 15 days for 15 degrees.
Brian, please stop.
Brian, listen. It's in their model, bro. The 4 minutes is made up for it due to the orbit of the Earth.
It is, Brian.
Listen, tell me this. How many days is 1 degree? How many days changes the globe 1 degree?
About 1 day, man. It's not exactly, but about 1 day.
So 180 days. How many degrees is that?
180.
So exact opposite, right?
Right. We agree.
Okay, good. So you're looking exactly opposite. 180 days later, you're looking exactly opposite.
Okay, listen. I understand, Brian. I understand your argument there. Yes, we agree up until that point. You're right. If it were perfectly 24 hours and we do this for 6 months, you're 100% right. We would at noon be it would be nighttime at noon. You're 100% right. The problem is you're forgetting that this 4 minutes per day make up for
the science of science. $5. What's up, man? Thank you very much. So just another coincidence that the Earth spins perfectly to keep day and night perfectly consistent. The Big Bang is amazing. Isn't it amazing? We're in this explosion. All the matter that we see, everything we see, all the planets and stuff, exploded by a point that was smaller than the tip of a needle, supposedly, some shit like that. And it's exploding outward for who knows how long, for who knows where, and everything just sinks perfectly as we spin and rotate at hundreds of thousands, millions of miles an hour, depending on what frame of reference you're looking from, tethered to a fucking giant ball of gas. It's quite remarkable. I mean, if I was a god, that's definitely how I would design things. That makes total sense. Thanks, Science of Science.
So facing the way it
I also thought it was nice to get a short break from the discussion.
Should the globe be facing it after they've done their math? Which direction should it be facing? Is it facing toward the sun or away from?
Okay, well, hang on.
The math works for this. I'm telling you guys.
Listen, I'm asking Paige. I'm just trying to. I'm hearing different stuff. I'm trying to process it.
Yeah, hang on a sec. 360.
Just stop.
That would make me there. Okay, so if I go 360 around this with this, all the way 360, I'm now facing the same way. But then if I turn that thing 180, my dot is now facing away from the sun.
New scenery.
Hold on. Yeah, shush. Okay, so when you were 180 degrees before, you had the
around this side.
You had the even number houses. And then you turn 180 degrees and you're facing the opposite direction. You have the odd number houses. Now,
thank you,
hold on. What I hear you saying, and this is my little tongue-in-cheek joke about it, is you're saying that somehow the zodiac follows us all the way around as well, so that when we do look opposite, we see the same stars, which is what I call...
Sorry, I was talking about the sun, not the stars. I wasn't thinking about the stars at all.
Yeah, well, I was talking about Orion being an equatorial constellation.
Okay, hold on again. But we are not talking about the sun. The sun is in the middle. We are never facing the sun at midnight.
No, you'll be facing away. Yeah, so you should see different stars.
That's what we're saying. But we don't.
Okay.
We don't.
Yeah, thank you, Travis. That's what I got on my video of Orion. It's an equatorial constellation. It can be seen from the northern and the southern hemisphere, and it can be seen sometimes like 12 months or like 11, 12 months out of the year if you're on a mountain and shit. But 9 months out of the year, plain as day, when you should be looking over the equator, you should be looking to an opposite region in space, not just a different region, an opposite region. I know it works with Polaris.
They'll
and
just
things
say
like
it's so
this.
far away.
You're not.
They'll
You're
just
not.
go, oh, it's so far away that
You're
you know,
not
it makes
seeing
no
opposite
difference.
region. It's the same stars. You're still, relatively speaking, you're still looking up because the hemispheres don't switch. It's purely the rotation. So
Right.
Well, I put you on the equator, buddy.
Yeah. Here's
what you'd refer to essentially would just be at the same time 6 months later. This star is not in the same location relative to my eyeballs on Earth, but you're not going to see
Jeremy, just
new
give it.
stars.
Jeremy, give that 100. I'll cut it down to 50. Jeremy, just give it out to Brandon when you get
No,
it.
because now what you're saying actually makes a little bit more sense. I thought you were trying to argue that we would be facing the wrong way because we losing the 4 minutes a day or something. If you're just talking about in 6 months, we should be looking at
What I was
different
thinking
stars.
too.
Yeah,
me too.
You don't
in
switch
6
the
months, as far as
so
this
you're
star
all
thing,
welcome. You're all welcome.
Thanks,
Thank
Travis.
you.
Thank you. Yeah.
Travis
Thank
is
you.
a hero tonight. Thank you, Travis.
He's your hero, Brian.
Yeah, I'm just fucking with you anyway, Jeremy, man. You know
I don't think you thought this through at all, to be honest. In my opinion, you don't switch hemispheres. You don't get new stars. You just get stars in different locations in the sky.
That's why
at that same
I
time.
use midnight and on the equator during the equinox.
Right.
That's the point, Bio. We don't get new stars, and we should get new stars.
Why should you get new stars? It's the same. It's the same
Because
field
you're
of
looking
stars.
180 degrees.
Because you're
Listen,
looking
okay,
away
here's
from
this,
the
now here it is though, guys. Here it is. Just like we never see the rotation of the moon because it's tidally locked to the Earth. The reason why we never see stars that are new is because of celestial locking. It's just locked step. It's just like the fucking atmosphere. It just goes with us.
Hold on.
I
There's
think
something. I think
good.
Bio might have a
Brilliant.
point here. Like,
So
okay,
you
so
cannot-
we're 180 degrees, right? So our solar noon is 180 degrees. But when you're thinking about what stars you see, you got to take into consideration as soon as it gets dark and up until just before daybreak. So the entire time it's dark, and the directions you can look off of the Earth everywhere in between, you can look more than 180 degrees of the sky because you're rotating from position to position. So you can actually kind of look at probably like 3/4. I'm sure it's calculated somewhere, but you can kind of look behind where you would be at solar noon or whatever the hell it's called, or solar midnight, right?
Right.
You see more than you can see at solar midnight.
Right. You're still seeing the same stars, just in different positions. You haven't changed your place in the for the globe model. You haven't changed your position in the galaxy, and those stars stayed the same spot. So now we have new stars. You're
6
rotating around
months
the same star, looking in the same direction. You're still, for the northern hemisphere and for easy comprehension, you're still looking up this entire time.
Yeah, 6 months later, as Brian stated, on the equator, 6 months later, you shouldn't be able to see the stars you saw 6 months ago because you'd have to be looking through the sun to see those stars.
Oh, not all of them. Yeah, those stars, that there's a certain portion of stars you should never see at that time, but it's not like just half the stars.
My Earth was looking through the sun.
This is why particular constellations show up in the sky at different times of the year.
Yeah,
Look
but
up
Orion is an equatorial constellation, bud.
Right. So look up the Southern Cross and where it is at different parts of the year. It changes its orientation because we are.
Orion should be almost 180 degrees. You could argue 150. Okay, I'll give you that. But you should never see it. It's an equatorial constellation.
If you can see the southern celestial pole, you should be able to see the
Science for Science, $2. Thank you again. He says, the moon also spins perfectly. It's a good clock. That it is indeed. I wonder if that is its true purpose. I have a feeling it has another purpose up there. It's doing something that we just can't fully, or at least I don't fully comprehend. Or maybe it was like the previous iteration of suns and it burned out and they put the new one there and they're just like, fuck it, just leave that old one. But yeah, I don't know. Or maybe they rotate. Like that one will come on, another one will go off at some point. That's just my brain though. Thanks, Science of Science. Thank you.
Empirical.
I just explained how it is.
You just
empirical.
don't understand it, Travis.
No, you
I
just don't
explained
understand.
how it is. I just explained how it isn't.
I know you explained how unicorn farts can power the sun.
And there we
but
go. We
have
devolved. It was a good conversation
you have
until this
no evidence.
What's the contradiction?
happened.
What's the
I'm not
contradiction?
talking to you. I'm not talking to you, Sea Lion.
Well, if it's a logical if it's illogical, that means that there's a contradiction. Where's the contradiction?
You're too idiot to understand anything, Brenda. They try to explain you for half hour, like something for half hour, and you
We've been explaining like this is.
The way it was explained to me was if you draw it on a piece of paper, right? And so make a dot, which would be Orion, put the sun in the center, and then put the Earth in between the dot and the sun. Okay? And so say that's whatever, the summertime. And so you're facing away from the sun and you're facing Orion. Now move your Earth to the right side of the sun. And now you're looking at and at nighttime, you're going to be looking in the completely opposite direction from where Orion would be.
Now, because of the ecliptic, I grant them 23.5 degrees, but that's all they get. So anything that's outside of 23 degrees of the equator, I mean, inside of it, they're screwed.
Yeah, the sun would be blocking out all the stars you could see 6 months later.
No, it wouldn't.
Yeah,
at midnight.
Some stars
the ones
actually.
at midnight.
Yeah.
All the stars you can see at midnight. 6 months later, you shouldn't be able to see any of those stars.
The sun blocks out all the stars at midnight. You're right.
No, the sun would.
Did you think about this? Because there are of course these stars in the north, there are stars in the south, and the stars on the equator. Now, if I'm not wrong, it's my understanding that of course the equator would point towards the sun, so it won't be the equatorial stars would change throughout the year. But the North Pole, if I'm not mistaken, doesn't point towards the sun, and the same for the South Pole. So the north and the northern and the southern stars wouldn't change.
I agree. That's why I used Orion, because you can see it from the northern and the southern hemisphere.
But you can't see it year round, Brian. You can't see it year round.
You can see it almost for you to be able to see it 6 months in one day is a problem. You can see it for at least 9 months. Okay, and sometimes you can see it for 11 months, depending on where you're at.
Even in the northern hemisphere, you can't see it.
You have a false expectation, Brian. That's what this is
Just
rooted
go
in.
watch my video. I show it. Okay, I don't like all this talk. I like demonstration. I show fucking Orion on the fucking astrological fucking different websites. Not just one, but a few. I show it from the south. I show it from the fucking north. I show its position in stellarium. I show the time, the calendar. It doesn't fucking work. It's a globe killer.
I still think that you're misunderstanding and you have a false.
You should watch his
Brian.
video. Then watch his video.
Brian, have you seen Mitchell's sextant video yet? At the end, he shows a map. Yeah. Have you seen the map at the end with all the stars mapped out?
Yeah.
They've got all the GPs of all the stars. Oh my God, go and look at it. It's a Mercator map with all the stars mapped out above it.
Brian, you might have something with this star thing, I think. I don't know. I might have to look more into it, but.
Yeah, granted, okay, I'll give them that. The north, the Polaris would be the same all year round if it was a gajillion fucking miles away. Okay, they got to put it, but that's why I used a fucking equatorial constellation. Okay, one that can be seen from the northern and the southern hemisphere. One that's right there by the equator. Okay, it breaks their model. People don't understand what I'm saying. Even y'all just had the tendency when I let off talking about Orion and the equator, everybody naturally went against me because they've confused us into thinking bullshit. But for it to be seen 6 months in one day breaks their shit. But I show it seen 9 months out of the year and 11 months in one spot on a mountain.
I think what you have to do if you want to show that some kind of celestial observation defies their model per se as they've defined it is show a contradiction between what you see in the real world against whatever they consider their official model of the celestial, I don't know, stellarium or something like that, and say,
Yeah, well,
look,
yeah,
stellarium
exactly. When you
says,
go to Stellarium, though, man, check it out, Brandon. When you go to Stellarium, you probably have been there, but a lot of people haven't. You go and you look at Stellarium, and they have to fucking warp that shit like you wouldn't even believe. It makes me feel drunk when I look at Stellarium when you start moving shit, dude. It's so warped and fucked up, dude.
Brian, that's why it's so
globe,
hard. That's why it's so hard to falsify anything with these celestial observations, anything in the sky. That's why little people just throw up their hands and say, "Fuck it."
No, you just
Yeah,
have to.
that's why I like to use a globe. That's why I recommend everybody buy a globe and put it in the middle of your room. It's already got the tilt, you know. Put it in the middle of your room and get a spotlight and a little laser. I've did the freaking. I've showed how the what you call it, the analemma doesn't work. Okay, and I've showed. I've showed how the Australian sunrise broke. I'm working on a new one, but some of them are arguable, but some of them are common sense, like the 180 degrees at the equator. Even if
Brian,
you give them the 23 degrees, it's still messed up.
What's that video called?
Something about Orion. Okay. Damn, hold on. Let me see if I can find the name of it. I'll post it.
Yeah. Okay. Thank you.
But what Brandon said is correct. In order to refute a model, you have to show a contradiction within the model's terms.
And we will see a different set of stars 6 months later. 6 months later, we will see a different set of stars. I mean, on like an AE, planar Earth type model with the idea of the stars above that are moving in 23 hours, 56 minutes, and the sun's moving 24 hours. So essentially, the sun is losing pace on the stars very slightly, which is why it causes it to move in direct motion through the zodiac. Direct motion means it's actually losing pace on the fixed stars, which is why it's doing that 1 degree a day, and it does that in one whole year. So the fact that that's happening, the only stars we're going to see are going to be the ones that are on the opposite side of where the sun is like in its process of losing pace with the fixed stars. We're going to see the stars that are 180 degrees opposite of that. Of course, I was just going to say minus like Polaris and the Southern. That's a little different. I'm talking about the main band of stars. Yeah, go ahead.
So when did you have a model? Because I've been told flat earthers don't have a model.
Well, isn't it amazing that we lose that the sidereal day is 23 hours and 56 minutes, so we lose 1 degree, so it's this perfect
Right. So
amount
that's
of
where
rotation.
that's where I was.
Miraculous?
Right. That's where I was going to go, because I think, and again, we get castigated for not having flat Earth science. Okay. Well, forgive me for not being able to do everything besides take photographs and analyze the stuff that I'm doing with the photographs. So I can't do everything. However, if we consider the possibility that the Gregorian calendar that we have now with the solar measurements of time, as opposed to the ancient Near East and the Orient that were lunar based, where you have 13 months, okay? When you look at it that way, everything from that perspective has more compatibility with what we understand nature to represent to us, right? Which is why September is the 7th month, October is the 8th month, right? November is the 9th month, and December is the 10th month. That's why it's 7, 8, 9, 10. But we have now been dislocated from nature. We have been given a false calendar and clock, and so they have to then manipulate and molest time. So if we were to go back and hold on. So if we were to go back to a lunar calendar and look at this shit, I think that the globe model wouldn't be able to stand up under the lunar calendar.
Fantastic.
Yeah.
I'd like to correct myself to a particular extent and clarify something. I posted in the chat that your local midnight, you will have different constellations in different positions, but you do get
not the way you should, though, bud.
If you want to be pedantic, quote unquote new stars, new constellations, but they're not new. They're just for your local midnight. They are new. But the link is in the chat. I misspoke about. I probably wasn't clear enough, but there you go.
Fair enough. I posted my video also, and I posted it in general, and like I said, yeah, that does work. Okay, there and everything we're talking about, that doesn't hold up, okay, they do have excuses for it. They say the sun hovers on the horizon and shit. Everything that doesn't line up, all reality that doesn't line up with the globe model, they use math. They have an excuse. Okay, it's a good model. Okay, it's a simple model. It's outdated, and we're trying to move forward. And help us instead of trying to argue against it. Help us figure some of this shit out. You know, like
if you come-
refraction and where the sun's at. If we put our heads together, we could advance.
Well, if you would come with observations and a model, that would be helpful.
We're working on it, man. I just posted, everybody, man, I'm just saying, if we put our heads together, like Mitchell from Australia, whoever ain't subbed to him, he's simply brilliant, man. He keeps it simple.
Any evidence or
Shut
observations?
the fuck up.
How come every time I go to talk about Mitchell, you interrupt me, Brendan? Every time I try and give Mitchell a shout out.
Why?
He's a young man. He's a young man. Go ahead, Travis.
Here we go. Here's going to be the proof in the pudding. If you would look at my second to last video, it's the newest second to last video, and just take the time to absorb the information that I put out in that video. If you want to refute the video content, by all means do it.
Could you post a link to it, please? Pretty please.
Be happy to.
I think Travis made a really powerful point earlier with the lunar calendar. People don't realize it, but 13 months and you have 28 days in a month, and it works out perfectly.
Yeah.
The Gregorian calendar was not working. That's why we switched.
Okay, hold on. No. Listen, that was my point. You just made my point.
No.
They switched to the Gregorian because the lunar fucked up the globe model. That's why they had to create a solar calendar. So thanks for proving my point.
Yep.
That's correct.
There's actually one thing that needs to be brought up. Days are sort of arbitrary, aren't they? So days aren't actually, some magical thing that has to, work up perfectly. Because they are sort of, it's an arbitrary line how you define it.
Well, that's what they've done.
For example,
there's a 28-day lunar cycle, right, for the moon, and that works out to 4 7-day weeks, right? So it's not arbitrary.
Why would it have to be? Why would it have to be perfect? For example, let's take a comparison. Let's say you're walking from your house to your neighbor's house. Does that have to be 28 meters exactly, or an exact figure, or can it be like a kilometer and 3/5? Should it be some neat number?
No, this is not.
Number?
This is a false equivalence. I
Well,
don't
when
even understand what
it
you're doing here.
resets every year, like the sky does, yes, it has to be perfect in certain ways. Yeah.
Right.
Lori,
I don't think
you can choose when.
Tango 24. What's going on? $5 New Zealand. You guys are 2,500 years too late. All this stuff is figured out. We have robots on Mars and probes near the sun. Mankind has moved on. Wow, dude. Okay. If you say so. 2,500 years ago, huh? Wow. As always, Kango, you bring the heat. Thanks, man.
But then we have the lunar calendar, and that's sort of determined by the moon.
Right.
So why should the moon follow exact days? Why should it fit neatly?
It just does.
Listen.
It does.
The sun is the time tracker of the day light. Okay, so we have longer days in the summer, shorter days in the winter, right? The moon
depends on where you are, right?
Yeah, sure. Yeah, the moon is the monthly calendar, and the zodiac is the seasonal calendar. It's all very simple. It's a clock. it is perfect. If you want to use
Okay.
the term of
It's not a
Okay,
perfect
well,
clock.
Yeah,
and-
days,
and-
months, years, and
okay,
ages.
hold on.
It is.
Hold on.
It is.
Hold on. Why is it not a perfect clock?
I will then.
You're going to be a day off, and over time you're
A
gonna
day
have,
off from what? No,
you're
no,
gonna
no.
have-
A day off
No, no,
from
no,
what?
no, no, no,
From-
no, no.
from
Yeah,
what?
a day off from
No
what?
way.
Wow.
A day off from what? A day off from what?
3 words. I said 3 words, and 4 people wanted to shout.
Yeah, because that was retarded.
Because you're being ridiculous.
Because 13
Yeah,
months.
it's a day off
Yeah,
from
you're
what?
retarded.
Oh wait. We're good. 13 months and 28 days comes out to 364 days. We're gonna
That's
be
it?
1 day. From
Oh,
this.
you mean from a day off from the calendar that you made up, right?
Hold the fucking phone, man. We're gonna be off for 1 day. We're gonna be off, and given enough time, that 1 day off is gonna
Your
be
model.
adding up. Holy
Off
shit, man!
from
It's not
what?
the
You
lunar
fuck?
cycle. The lunar cycle is
Look,
not off.
He still
I
hasn't
could
answered off
explain it.
from what?
I could
You're
explain
so
it,
smart.
or
You got to
I
come
could
up with that. You're not
Never mind.
smart if you're
No, you got
you're
this.
saying this.
You
Yeah, I
got this,
know.
smart guy. Go ahead.
I know some dumb guy, some dumb concrete finisher knows you're being stupid.
Yeah,
Because
that was
that is not
retarded to
that
say.
is not the model.
A day off of what? You made the fucking model. How is the nature gonna be? How you are gonna overtake what the nature dictates?
Yeah, how are you
That's
going to
fucking
tell
retarded.
nature they're a day off?
Yeah.
Nature,
Nature's all
nature,
day off.
nature
day
rules
off.
over your fucking models
All
and
these-
shit, buddy.
all these
So a day off
questions and
of what?
all these
Of your
questions,
model
and when
that
I-
you built?
No,
all these
your
questions-
model is a day off of
Oh,
the
never
lunar
mind.
cycle because y'all
Fucking
made it up.
Thank you.
Don't
Exactly.
know why. Don't know
Dumbass
why I
shit.
try. When all these questions come up, you attempt to answer, and you're
Nobody cares
constantly
about your
interrupted.
We don't care what you're saying.
And
We
don't
don't
ask
care
them. How
what you're
about that?
saying about your
Don't ask.
model.
Holy shit.
Don't ask.
We don't. No,
Okay,
I didn't
let's-
ask
guys
you
are
about
beasts.
your
Let's
model.
listen. Let's try to bring it back again. Again, bio. I asked you a simple question, and you gave us word salad. Please be as succinct as possible. Hold on. Shush.
If I could get to the end, it wouldn't be a word salad. And still just interrupted. It's so
Bio.
funny, man.
I can't hear you. I didn't know it was you. Listen, again, the question is, you said the calendar is still off. Off from what?
There is an established revolution in which it takes a particular amount of time, and you can match that up with the
I'm
seasons.
sorry,
This is
revolution?
again,
Revolution
man.
of what?
Again, I don't even think I put a period at the end of my statement, and I was already interrupted.
A revolution from
You're
what?
not answering the question.
No, I've tried 4 or 5 times now.
You're not
A revolution of what?
What do you think when I, as a globe Earth, talking about the globe model, say revolution? What do you think I'm talking about?
Great. Now you
Time
are
for
now
obfuscation.
just
He doesn't want to answer, so he's
you
just
are
going to
now-
rabbit on about format
Paige, listen. A revolution around the sun, being Earth around the sun, a revolution. That's
Right.
what it's on a globe model. God
Right.
damn. Why do we have
Listen.
to ask these questions?
Listen, for clarity,
Holy
okay,
shit.
listen. That's why you're off, because you're imposing a false model upon
Exactly.
nature. And when that
go.
model
I
doesn't
still
work,
haven't even explained it, but sure.
you don't need to. You're already
You
presupposing
just did.
that
You
you're on a
said
fucking
revolution.
ball. Yeah.
Yeah,
You
that
just
was-
have to
that's
do it because you're
all I
reversing
wanted to
your
say.
numbers.
It's
Kyle,
really
let me say this.
simple.
Right.
It's
Nature
say
is
this.
correct.
Let me say
It's
this.
not
I
off
just
a
wanted to
day
say
from your model.
revolution.
Your
they have
model is
all I
off
wanted
a
to
day
say.
from nature.
I wanted
Because
to say
when they
one
were
fucking
reverse
word.
engineering this, it didn't work, right? So they had to make this shit up.
It's
That's
really
what-
simple.
Hey
Yeah,
guys,
you
can
don't
I
need
break
to-
in for a minute? Sorry, I didn't mean to stop the flow. But I just wanted to thank everybody on the panel for joining tonight's meeting. Joining tonight's show. Thank you very much for being on the panel. It was a good discussion, and actually learned a thing or two tonight. So I do appreciate that. I will continue to record after the show. Probably be recording all night as usual, just so you're aware that if you're in the room, chances are you're being recorded. So thanks again. If anybody that didn't get to speak during the show or just has something absolutely burning to say,
Thank you.
Go ahead.
Horizontal.
Just want to say, great show, Brandon. Thank you. That was it.
Thanks, Salazar.
Gerbils lives matter, Brandon.
Oh, you're right.
God's creation is not perfect.
And then,
you're a shining example of that, Brender.
one
She just admitted we're all God's creation. Well done. Good on you, Brenda.
We're gonna have to change the meme from "Thanks Bob" to "Thanks Bob and Alice."
All right. I think that's good. Thank you guys for listening. Appreciate it. Crowd was a little light tonight. I think there's a baby truther show on or something. Those guys are cool sometimes, but I just don't ever get around to watching Jaren stuff as much as I used to. I haven't gotten into that baby truther show. I don't know. But anyway, we'll be back tomorrow. Friday night fights. Somewhat moderated as usual. Keep the over talking down. It's been going pretty good lately, I think. And like I said, lots of people in the Discord, so come on in and hang out. And there is usually moderation in there, so it's not a giant shit show. So stop in. Anyway, we'll see you tomorrow night. And thanks again. Thank you to Kango24. 2,500 years too late, huh, Kango? Science of Science. Big shout out, Science of Science. Thank you, sir, ma'am. And Rob Keene. Thank you very much. Level is horizontal, of course. Try to disprove it. Try to disprove it. We'll see you guys tomorrow. Have a good night.
Understand